Good morning, California water reuse practitioners, and good day to those of you who join us from elsewhere across the United States of America. This is Kevin Hardy, and I'm the Executive Director of the National Water Research Institute. It is my pleasure to welcome you to the first meeting of the State of California's Expert Panel to review regulations proposed by the State Water Board to regulate the reuse practice known as Direct Potable Reuse, or DPR, here in the Golden State. John F. Kennedy was famously quoted as saying, "Anyone who can solve the problems of water will be worthy of 2 Nobel Prizes, one for peace and one for science." And while I'm not trying to say that anyone on this call is or is not deserving of international recognition and or large cash awards, I do want to remind everyone of the importance of the work that we start today and its legacy impact on the communities that we all live and recreate here in California. So again, welcome. Let's move to our next slide. The National Water Research Institute is honored to facilitate and administer this expert panel. Founded in 1991 by leading citizens and utilities across Southern California, many of whom are represented on this call today, our Institute Without Walls, an international community of practice, has for 30 years been the nation's collaborative resource for the advancement of water resources science, policy, and innovation, and the independent advisory services provider of choice for challenging water quality, water resource management, and related innovation issues. We strive to provide insight and understanding of current and future issues in water science and technology. And our role today and throughout this project is to assist the State Water Resources Control Board, its Division of Drinking Water, our panel co-chairs, and our expert panelists fulfill their respective legislative mandates as set forth in AB 574. And in doing so, NWRI achieves its mission of helping to create new and healthy sources of water. Next slide. So we want to take a moment to introduce you to our expert panel, and we're going to have some time later in the morning for the panelists to give self-introductions. But writ large, this is a remarkably talented group of experts that includes Stockholm Water Prize winner, 3 Clark Prize laureates, and folks with substantial depth from across the academic, research, engineering, public health, and utility management perspectives. And this group has been working hard in preparation for this effort. Each panelist received documents including the DPR Framework 2nd Edition Addendum, early draft of anticipated criteria for DPR, the proposed Framework 2nd Edition, which the early draft built upon, the 2016 DPR feasibility report. In addition, each have received links to the State Water Resources Control Board webcasts produced earlier this year that took the deep dives into pathogens and chemicals of concern. So this group with its chairs, Mr. Olivieri and Mr. Crook, is well led, is properly resourced, and stands ready to do the work required by AB 574 to make the finding whether, in its expert opinion, the proposed regulations would adequately protect public health. We're humbled to work with this and learn from this remarkable group of experts. And I want to acknowledge and thank each of you for joining us on this journey. Let's go to the next slide. Take a minute to review the panel charge. The meeting process and timeframe for completion is really the first objective of today's meeting. We want to take the time today to set an appropriate foundation for the panel's future work. So we'll also spend time educating the panel members on the current status and goals of the project, allow some time for the panel members to identify topics or interests of concern, and present the draft DPR criteria and provide time for panel questions. Let's take a look at the agenda on the next slide. So we're in the welcoming part of our agenda, and we'll try to stay on track here as we review the agenda and some of the panel process. We'll move after this part of the agenda, we'll move into a conversation with your co-chairs, Adam Olivieri and Jim Crook, who've been working hard to prepare some introductory material that, again, will work towards establishing a baseline for all the panelists to have as we transition into this hard work. So we'll spend time discussing the meeting process, doing the self-introduction that I mentioned, and establishing that our panelists are free of conflict of interest, or that we identify any conflict of interest and we move forward appropriately. After we conclude with that, Adam and Jim will continue on with an overview of the DPR feasibility report. We'll take a break, and then the DDW project staff team. And we've got a number of folks on the call. Jing Chow, who's been our project manager, I want to acknowledge her help in getting us to this point. And I see Randy Barnard, Bob Hultquist, Brian Bernados, Kurt Souza, and others from the state board who are on the call. And we look forward to hearing from you to provide a review of the mandate and the task for the panel, to go over the process for how regulations are developed, go over the criteria for drinking water regulations, and the draft criteria for DPR, and talk about next steps. Then we'll take a breather, take a lunch break, come back at 12:30, and then we're going to hear from Brian Pexton, who is the primary investigator on DPRs 1 and 2, and learn about that research, which should support these regulations and how it does so. And then we'll turn back to the DDW project team for about 45 minutes near the end of the day to give us a briefing on the draft criteria with a focus on the pathogens element. We'll try to wrap it up about 1:50 and get to panel questions, and our commitment to you is to be done by 2 o'clock today. So I want to acknowledge all the presenters. There's been a lot of diligent work to get prepared for today, and we appreciate each and every one of your efforts in support of the panel and of NWRI. Yeah, let's move to the next slide. We'll talk about ground rules. And this is where I'm not seeing this. Okay, so today we've been living in this virtual world for quite a while, and I think that we all know that this forum requires patience. So we appreciate your patience. We want to encourage you to keep yourself muted unless you're recognized to speak, and to keep your camera turned off. It just creates a little bit more bandwidth for everybody to use. The GoToMeeting platform supports internet or phone audio. If you're using your phone, use the audio pin and put your name in so we can identify who you are. As much as possible, and I know this is going to be a challenge for some of the folks for whom it's the middle of the night, but let's remain present and minimize multitasking, but take the breaks you need. We want to keep you engaged and keep you through the end of the meeting. So do what you have to stay engaged. We understand that we're kind of operating in a new world, and so everybody will be patient with each other's needs for rest and recovery as we go through these kinds of online meetings. The question and answer periods today are for the expert panel members only. And I think if the recording has not already been turned on, I want to let you know that the meeting is being recorded. Next slide. And finally, we do have, I want to speak to folks who are interested in making public comments tomorrow. We do have public 30 minutes reserved on the agenda to receive public comments tomorrow. There's some process that we need you to go through so that we can identify who you are and get you queued up to make your comments. I understand that within the 30 minutes, we're going to have to do some time limitation to make sure everybody who is interested in commenting can have that opportunity. I think now we're thinking about at least a 3-minute limit, and we'll have to decide a little bit later when we have a better sense of all the potential commenters whether that 3-minute limit is appropriate. But we're going to do everything we can to accommodate public commenters. But get an email in if you haven't done so already to DDW Water Recycling Boards at that address there. It's also available on the DDW website for this project. Put that DPR criteria expert panel meeting number 1 in the title line. Then they need your name, who you represent, yourself or an organization, how you're going to get there, and then if you're going to be a phone commenter, you've got to give them some additional information. So that's for tomorrow. I encourage you to make public comments, and I look forward to facilitating that process at the close of the meeting tomorrow. But with that, I think it was Confucius who said, "A man of wisdom delights in water," and if that's true, then your two co-chairs, Adam Olivieri and Jim Crook, definitely are men of wisdom. So with that, Mr. Crook, I'm going to turn it over to the co-chairs. We're going to advance to the next slide, and maybe even the slide after that, Jing. And Jim, I'll ask you to take it away.
Thanks, Kevin. Yes, I am the co-chair along with Adam. I won't go into the process of who we are. I think most of you know us, although when we get to the introductions, we'll just briefly describe our background. But We're going to talk about various things. First of all will be the potable reuse in California, obviously, and regulations and research topics. And the expert panel process will include introductions, establishment of the no conflict of interest, the panel charge, and meetings, work groups, and schedule. In background, we'll talk about current regulations, which include groundwater recharge and surface water augmentation, which are both indirect potable reuse projects. And direct potable reuse, DPR feasibility, the expert panel findings from the first expert panel, regulations and definitions, and investigations. Next slide, please. This is where Kevin mentioned self-introductions. So I will first tell you who I am. I'm Jim Crook. I used to work for the State Health Department from 72 to 88, then with a series of consultants until 2002, and I've been on my own for the last 22 years. And it's mostly been in the area of water reuse. Helped write early versions of the regulations, for example, but not since I left. That's about all I want to say. Adam, did you want to give us your background quickly?
Yeah, sure. Adam Oliveri, I'm civil environmental engineering and public health. Spent some time with UC Berkeley, some time with the State Water Board, and many years as a consulting engineer.
Very good. Thanks, Adam. I'd like to hear from each panel member, and I'll do it alphabetically. So Dick Bull is first in line. Could you just give us a few sentences about your background and what you bring to the panel?
My first job was a dishwasher in a restaurant, so I've started way back. But since then,
Okay, thanks. Thanks, Dick. Next we have. Go ahead.
I actually started making a living for myself. I was working at the EPA for many years. Then I went on to academia at Washington State University and finished up my active employment career with the Pacific Northwest National Lab. I'm a toxicologist and spent most of my time working on research into various contaminants of drinking water.
Very good. Thanks, Dick. Jörg Trevis, Germany.
Yeah, thanks, Jim. My name is Jörg Griffis. I was on the faculty of the Colorado School of Mines for 12 years, and since 2013, I'm on the faculty of the Technical University of Munich in Germany. My specialty is advanced water treatment processes related to potable reuse, and I also served on the previous NWRI DPR panel, as well as shared multiple CEC panels for recycled water for the State Water Board.
Thanks, Jörg. Is Chuck Gerber online?
Yep.
Oh, good. Go ahead, Chuck.
Yeah, by training, I'm a virologist. I spent my whole career actually studying viruses in the environment. I spent 8 years in the Department of Virology and Epidemiology of Baylor College of Medicine before I came to the University of Arizona. I'm now in the Department of Environment, located at the Water, Environment, and Sustainability Center. And I have my dream lab because I have sewage on tap. Here's something I've always wanted because I'm only 100 yards from a sewage treatment plant. But largely, my background is environmental virology.
Thanks, Chuck. We have another Chuck Haas.
Hi, Chuck Haas. I'm professor of environmental engineering at Drexel University. My main areas of interest are microbial risk assessment and quantifying pathogen removal and treatment processes. I was on 2 of the National Academy of Water Reuse committees and had been on multiple NWRI committees as well.
Thank you, Chuck. Amy Pruden.
Hi, I'm Amy Pruden. I'm a professor of civil and environmental engineering at Virginia Tech. And my area of expertise is environmental microbiology. And I work with a variety of pathogens, mostly bacterial pathogens and looking at antibiotic resistance. And I've been a PI or co-PI on several projects related to water reuse.
Very good. Thank you, Amy. Joan Rose?
Hi, everyone. I'm Joan Rose. I hold the Homer Nolan Chair of Water Research at Michigan State University. I'm a professor, and my field is health-related water microbiology, and study both parasites and viruses and bacteria in water. I've been involved in reclaimed water since the 80s. Worked in Arizona, in Florida, Singapore, and California on wastewater reuse. Both non-potable and potable, and very happy to be here. Thank you.
Thanks, Joan. Shane Snyder?
Hey, so good morning from Singapore. I'm Shane. I'm a professor at Nanyang Technological University here in Singapore. I'm also the executive director of NWRI, which is a large water and environment center here in Singapore. Funded by Singapore PUB. And before that, I was a faculty member at the University of Arizona for 11 years. And before that, I worked with Southern Nevada Water Authority for 10 years. And I'm predominantly working in emerging contaminants and water treatment processes related to pollution abatement. Thank you.
Thank you, Shane. Jacqueline Taylor?
Good morning, everyone. I'm Jacqueline Taylor, and I'm a retired Director of Environmental Protection for Los Angeles County Department of Public Health. I'm also a member of the National Blue Ribbon Commission for On-Site Non-Potable Water Systems. And I really hope that my contribution will be based around public health protections, education, and advocacy as we go through this legislation.
Thank you. George Shabanaglas?
I'm George Chabanaglas. I'm a professor emeritus of civil and environmental engineering, and my specialty is basically wastewater and treatment, reuse. And most recently, I've been looking at alternative source control and treatment technologies.
Okay. And last but not least, Mike Wayna?
I had kind of a long career, 20 years with the Orange County Health Department, where I was responsible for water quality control, including the development of reuse in Orange County from Hermione Ranch Water District, Orange County Water District, and large-scale potable reuse, beginning with Water Factor 21. And then the last 28 years with the Orange County Water District, actively involved in the development and water quality control measures for the groundwater replenishment system, which I think is still the largest potable reuse project in the entire world. Good for me.
Thank you, Michael. And that's our esteemed panel, and an excellent one it is. Thank you all for taking the time to give us a little bit of your background. We also want to establish that there's been, will be no conflict of interest with the panel. So we came up with a definition of what we mean by that. I'll just read it to you. A conflict of interest is real when the expert panelist has interest in the outcome of the project that may lead to a personal advantage. For example, benefit a member of the expert's family and or friends, and which might therefore compromise the integrity of the expert panel's findings and recommendations. And there's a high hope that none of you fall under this conflict of interest. I think we're all safe right now, but if anything does develop, you'll know the reason why. We definitely want to keep this on the up and up and have no conflict of interest. The next slide, please. Jing. I should have probably shown this slide first. The panel expertise. There's a lot of different expertise in the that the panel has, such as microbial risk assessment, chemistry, microbiology, water treatment engineering, wastewater treatment engineering, toxicology, multi-barrier system reliability, public health, potable reuse operations, water recycling regulations. Some of these are actually required by the state for the expert panel, but our expert panel certainly includes all of these, with multiple people being involved in several of the expertise involved here. Next slide, please. Let's talk about the panel charge, meetings, work groups, and schedule. Next slide. Okay, the enabling legislation is Assembly Bill 574 in 2017. And it's since been added to the California Water Code, CWC. It requires the State Water Board to adopt proposed regulations on or before December 31st, 2023. And that's the goal that we're striving for. Prior to adopting the proposed regulations, DDW, which is Division of Drinking Water, which is now part of the State Water Resources Control Board. For those who don't know, it used to be part of the Health Department. They moved over several years ago. But prior to adopting the proposed regulations, DDW must submit the proposed criteria to an expert review panel convened pursuant to Water Code Section 13561.2-C. The California Water Code requires that an expert panel review the proposed criteria and adopt a finding as to whether, in its expert opinion, the proposed criteria would adequately protect public health. That's the ultimate goal of the expert panel review. Next slide, please. In addition, the statutory mandate for external scientific peer review codified at California Health and Safety Code Section 57004 states that the reviewer's responsibility is to determine whether the scientific portion of the proposed rule is based upon sound scientific knowledge, judgment, methods, and practices. So it's codified what's required. Next slide, please. There will be, as far as the current schedule goes, and it's subject to some variability, there will be 4 to 5 full panel meetings. First one is today and tomorrow, and they're currently thought to be scheduled quarterly, could be bi-monthly or quarterly, but in a fairly lengthy time frame between each other through mid-2022. And we're also going to have much smaller work groups. And we're thinking they'll follow the first meeting, and we'll talk about this, I think, tomorrow. I'm not sure, and it goes right through till the end of the review process in December 2023. And we're currently thinking of having about 5 work groups, and there may be more, but they would cover subjects such as pathogens, chemicals, source control, TMF, an ability to adopt new technology without major revisions. These may be folded into other ones, but right now those are the 5 that we're thinking of. Next slide, please. Okay, in the background to current regulations, we already have IPR regulations for groundwater recharge and surface water augmentation. Next slide. This is just a schematic. The 2 on top are IPR. The ones on the bottom, raw water augmentation, treated water augmentation, are DPR, just so you know. And I think most of you know, no surprise, the groundwater recharge, surface water augmentation, putting it into a reservoir, then a drinking water treatment facility prior to distribution. Whereas direct potable reuse is much more direct. It can be from an advanced water treatment facility and a pipeline to either a water treatment plant, or directly into the distribution system, which would be called treated water augmentation. Next slide, please. Just another visual of groundwater recharge. Percolates into the underground, is withdrawn for potable or other purposes. Down gradient. Next slide. This would be surface water augmentation, where water is put in a recycled water is put into a reservoir where it mixes and is diluted to various degrees, and then is extracted and goes to a water treatment plant prior to distribution to the public. So this is still indirect potable reuse. Next slide, please. Here's a slide. The slide on top is the LA County Sand District's spreading basins in Whittier Narrows area. And I don't know what the bottom one is. But the environmental buffer has certain benefits. It attenuates chemical spikes. It's a robust pathogen barrier. It provides retention time. And it's the hand of Hygeia, which you can ask Adam what that means later. Next slide, please. The potable reuse reservoir augmentation pathogen control, typically in the treatment train can have eight logs of virus removal, 7 logs of Giardia, 8 logs of Cryptosporidium removal in the treatment train. And if you have a 1%, 100-to-1 dilution in the reservoir, you still have to get the 12-10-10 total logs of virus, Giardia, and Crypto. So it goes through a water treatment plant where you get credit for 432, comes out to 10-12-12. Same thing with, similar thing with surface water augmentation in a reservoir. You get 9-8-8 log removals of virus, Giardia, and Crypto. And since it's 10%, it's a log difference. So you need 432 again in the surface water treatment plant. So you have to make up that extra 1% in the treatment train. That's why it's 9-8-8 instead of 8-7-8. Next slide, please. We're the 2021 DPR Expert Panel. And in 2016, the previous panel had various wrote a report of their findings that include investigations, and there were regulatory definitions in there. Next slide, please. The findings were that, well, the expert panel assessed the DPR feasibility, and it concluded it is feasible to create uniform guidelines for DPR that are safe from a public health standpoint. The panel recommended 6 topics for further research. Next slide, please. DDW concurred with the first expert panel on the feasibility of DPR. More information on research topics is needed, however, before regulations could be written. And is a quote from State Water Resources Control Board: the use of recycled water for DPR has great potential, but it represents very real scientific and technical challenges that must be addressed to ensure the public's health is reliably protected at all times, underlined. AB 574 requires DPR regulations by December 31st, 2023. And the state board did write a report to the legislature addressing all of these issues. Next slide, please. Talk a little bit about the earlier panels, feasibility report findings, the investigations, State Water Board, Water Research, and the Water Research Foundation, WRF, and the regulatory definitions. Next slide, please. These are the 6 projects that were undertaken in the last few years, and all of them, I think all of them have been completed, but they're not all published yet. The first one is develop probabilistic analysis tools for DDW to assess treatment performance and quantitative microbial risk assessment. Collect pathogen data in untreated wastewater. Third project, which hasn't yet been published, is investigate feasibility of collecting pathogens in wastewater during outbreaks. Fourth project is evaluate options to reduce potential chemical peaks, and you'll hear more about that tomorrow's presentation. Investigate feasibility of analytical methods for non-targeted analysis of recycled water with focus on low molecular weight compounds. and 6. Those first 5 were funded through the Water Research Foundation. Number 6 was formed through a panel with the National Water Research Institute. So it wasn't Water Research Foundation funded. It was established an enhanced source control program. But as I said, the first 5 are Water Research Foundation grant projects, which are, if not available yet, all of them, they will be very shortly. They're virtually all completed. Next slide, please. This just shows where in the system we have to be careful of what we're controlling. You can see source control. That's out in the distribution system. Outbreak monitoring is very important. Pathogen monitoring of the incoming sewage to the wastewater treatment plant. And then control of chemical peaks again. As you get further down the line for the treatment. And all of this has to do with TOC, what's in the TOC, what you can monitor, when you should monitor it, how can you reduce the peaks, etc. That's all in the report that you will hear about tomorrow. The plant reliability and quantitative microbial risk assessment. Obviously, we're talking about the water we'll be drinking, and non-targeted analysis and low molecular weight compounds at the same spot in the treatment train. Next slide, please. Project 1, quantitative microbial risk assessment and evaluation of plant reliability. The goals are to develop methods to identify necessary removals for selected waterborne pathogens and apply this method to evaluate performance and reliability of DPR treatment trains. And the relevance? DPR must provide the same level of protection as drinking water, which requires risk-based goals. Tools allow the Division of Drinking Water to quantify public health protection provided by different treatment requirements, informs DPR regulations by providing insight into treatment criteria. You hear more about this afternoon. Next slide, please. Project 2 is measure pathogens in wastewater. And the goals are to develop recommendations for collection and analysis of data on pathogens in raw, that is untreated, wastewater. Conduct monitoring of raw wastewater to develop better data on pathogen concentrations and variability. In the relevance, the industry lacks sufficient high-quality pathogen data necessary for the development of regulations. New standard procedures will address limitations of previous monitoring efforts. Research will provide industry's largest data set of raw wastewater pathogen concentrations, and results will feed into evaluation of treatment in QMRA. Next, please. Project number 4 is treatment for averaging potential chemical peaks. The goal is to identify options for final treatment that can provide averaging with respect to potential chemical peaks, particularly for persistent chemicals. Relevance, defining what a chemical peak is, and you'll hear about that tomorrow again. Full advanced treatment, MFRO UV-AOP, is a highly effective treatment train used for groundwater recharge. However, fluctuation in chemical levels have been observed in certain situations. Management options, including source control, plant operations, and treatment, are necessary. Next slide. DPR Research reports available, and most began early in 2019, completed already in 2021. DPR 1, QMRA, is done. DPR 2, raw pathogen data, that's available online right now. And 3 is, Research Project 3 is the worst case raw pathogen levels and outbreak. That's almost completed. DPR 4 is reduced chemical spikes. That's available online. And DPR 5, analytical methods for unknown low molecular weight chemicals. That's also available online. And the site is where you can download them, is right there below that. Next, please. Okay, the 221 DPR Expert Panel. We looked at the 2016 DPR feasibility report findings, the investigations of the State Board and Water Research Foundation, and regulatory definitions. We'll talk about all of those separately. Next, please. The background, California Water Code requirements. California Water Code Section 13561 defines DPR as the planned introduction of recycled water either directly into a public water system or into a raw water supply immediately upstream of a water treatment plant. And there are actually two kinds of DPR. DPR is defined to include but not limited to the following. First, raw water augmentation means the planned placement of recycled water into a system of pipelines or aqueducts that deliver raw water to a drinking water treatment plant that provides water to a public water system. And two, treated drinking water augmentation is defined as the planned placement of recycled water into the water distribution system of a public water system. In other words, pipe to pipe. It doesn't go through a water treatment plant. Next, so you have those two definitions of DPR. And by the way, the regulations are being written so that the worst case, which is treated drinking water augmentation, is going to be the one that they're going to meet. And that is the most restrictive, but it will include all types of DPR that are currently under investigation. So that's why they picked that one. Next slide, please. Again, this is just similar slide to what I had shown you before. The indirect potable reuse is above groundwater recharge, which the regulations were adopted in 2014, I believe. Surface water augmentation are the newest ones a couple of years ago. And DPR is in light green underneath, the raw water augmentation and the treated water augmentation. And you can see the bottom slide from advanced water treatment facility to right directly to the distribution system. That's pipe to pipe. That's what the regulations are addressing, which will include the other type of direct potable reuse. Next slide, please. This is kind of a neat slide. It kind of summarizes, without a lot of the regulatory stuff, the sequence of events. DPR first began to be investigated through SB 918 in 2010, 2013 needed to develop a report to the legislature by 2016. The groundwater recharge regulations were finally adopted in 2014. And in 2016, the previous expert panel confirmed the feasibility of developing DPR criteria. And the final surface water augmentation regulations were adopted or became effective, I think it was October 1, 2018. And the state came out with DPR Regulatory Framework, second edition, 2019. 2021, DPR Regulatory Framework Addendum. And again in 2021, a little later in the year, DPR Priority Research completed. And the expert panel review and approval in 2022, and the regulations are proposed to be adopted by the end of December 31st, 2023. That's kind of a timeline. It's a very nice way of doing it. So everything's all on one thing. You can see all the history that's gone behind it. Next slide, please. I have to thank Randy Barnard for this slide. It's a great slide. Warning, challenges ahead. So keep your eyes open, and hopefully the state will be coming up with regulations that will be acceptable to everyone concerned. Next slide. There's a lot of paperwork. You have been given a lot of information already on some of the reports. We realize it's way too early for you to have read all or most of these at all, but eventually there's a lot of useful information that will be pertinent to task and deciding what's safe and what's not for DPR. Next slide. I think that's it. Thank you.
Thank you, Jim.
I believe that's the end of. Did I go too fast or too slow? Well, we had
you actually did really well. No, you did really well. I think before we take any next steps, I just wanted to open it up for Adam to see if there was anything that that he thought he wanted to add before we created some space here. I think we got a little bit of time for some panel Q&A if there's some out there. But Adam, anything that you wanted to add to support or reinforce what your co-chair just presented?
No, other than to just reinforce what Jim said at the very end, that we really didn't expect the panel at this stage to have read everything. And we will sort of take care of that as we move into the different work groups in terms of focusing, or, you know, you could read everything, we hope you do, but focusing on certain questions and then identifying other questions that, you know, maybe Jim and I have missed and are of interest to the panel to discuss.
Excellent.
Okay.
Thank you. Well, so Mr. Crook, thank you for digesting a decade plus of intense work by hundreds, if not thousands, of focused professionals in 40 plus minutes. It's a lot to take in, even with the big kind of overview perspective that you provided. I want to spend just a few minutes here because we've got a break scheduled at 10:50. This might be a good chance for the panelists out there to ask any clarifying questions that they might have. And this is one of those areas where kind of if there's something that missing, there really are no silly or stupid questions. I mean, at this point, if you're thinking about something, I'm sure everybody, other folks are as well. So if there are any questions a member of the panel has, this would be a great time to bring them out, let the co-chairs kind of take a stab at them and try to increase your clarity. Again, with the objective being that we want to make sure that everyone, all the experts, leave this meeting today with a foundational understanding of DPR and the status of this effort to the point where they feel comfortable with their command, so to speak, of the material. So any questions right now? Mike?
Yeah, I have a question about, I guess, how immutable the current structure is of lumping together raw water augmentation and finished water augmentation. That question came up from a number of commenters in the public comments that have been received. And I'm curious as to whether or not we're locked into the idea that we must have one set of standards for direct potable reuse, regardless whether it's raw water augmentation or finished water augmentation.
Well, I think
question.
It's a good question. I think that's not a question for Adam or I. It's more for DDW to respond to.
Yeah, and maybe this isn't the time to do that, but I think Randy, if you could jump on now. I know that for everyone's kind of just perspective, the next kind of overview perspective we're going to go into is a DDW one, but maybe Randy, you can give us a little preview.
Right. So as far as if we're locked in or not, it was more of a policy decision we made after right in between the first and second framework documents that we put out, based on the comments, and I'll talk about it a little bit during my presentation. I'll touch on it, but based on the comments and some investigations that we did, we found that there's not really a significant difference in regulating between the two types of DPR. So it just made more sense for us to develop a universal or overarching DPR regulation, and it encompasses all types of DPR. So we made the internal policy decision to move forward with just the one regulation that would cover all the scenarios versus trying to break it up. And what we were finding is if we were trying to break it up, we would just have to draw some arbitrary line between the two processes or between the two regulations that didn't quite make sense or have a solid scientific justification. So it just made much more sense to do one reg.
Thank you. Mike, that answer your question?
Not really, because the question is whether or not this is unchangeable and this is the direction we're locked into, or whether or not, based partly on the public comments that have already been received, any feedback that might be received from this panel, whether there's a possibility of separating and actually resulting in a different set of requirements for raw water augmentation versus finished water.
Well, we're definitely open to the expert panel providing that comment. If you guys feel that it has to be split, then it's something we'll consider. But we are not locked into having to do one. It was just a direction we took.
Okay, thanks.
Jim, could I ask?
My suggestion is to the panel, we have some time towards the end of the day. There are two different spots, I believe, in the agenda where we can ask clarifying questions. And I know we have a little time here, but maybe some of the questions that sort of piqued your interest, if you've read some of the comments that came in that large file, the zip file, maybe we can hold those for after, say, Bob speaks. I assume Bob is going to be speaking on the pathogen part. I could be wrong. Maybe
Adam,
hold him for there, and then hold him for those clarifying question spots, and then we can discuss them further as a panel as we move into the work group, and then have further discussions with DDW staff as part of those work groups, if necessary.
Adam, could I ask a question?
Yeah.
On what was just said, it seems to me that on the pipe to pipe, you're going to have to consider other things. For example, the effects on the distribution system, temperature effects of the advanced treated water, and how that will affect the performance of the existing distribution system. It seems to me that there's a whole area there that is left wide open and potentially could just lead to a lot of problems.
I don't disagree, George, and I think that's a good topic. That's what Jim and I were hoping to do we have a closed session coming up. We were hoping to capture those ideas and figure out which work group should actually discuss it and how to comment back to DDW staff in terms of whether it belongs in the regulation, whether it's already covered or not covered, or whether it belongs in some type of and I'm careful about the word guidance, but I'll use it here loosely, whether it belongs in guidance or part of the Title 22 engineering report. But George, you're right. You're absolutely right. So we're gonna try to collect all those different ideas that, as I indicated earlier, and try to either bin it into the right work group, or it may be another work group.
Yeah.
Good. Well, I don't see any other cameras that are on right now, and I don't see any hands raised. So with that, I'll assume that kind of the questions regarding clarification related to the decade overview that Mr. Crook just provided have been taken care of. If not, we can always circle back. Don't ever be afraid to ask a basic question. But I think at this point, when it's 10:49 by my clock, that gives us a whole extra minute. And maybe what we'll do now is everybody take a break, get up, stretch your legs. We're going to allow the DDW staff to transition presentations, and they're going to come back right at 11 o'clock at the top of the hour. I'll welcome them in to review their statutory mandate through next steps in this project as they see it. So take a break. We'll come back on at 11 o'clock.
Thank you.
Okay, it's 11 o'clock. Now it's time for DDW to provide their overview of their statutory mandate and tasks for the panel, provide some overviews on both regulatory development and drinking water regulation, and look both at the criteria as it stands in draft form today and next steps in the process. And to do that, we have Randy Barnard who'll lead his team off. I believe he's going to be joined by Kurt and Jing. Randy, take it away.
All right, thank you. So Jing, we can go to the next slide. So this is the speakers we're going to be having today. I won't go into introducing each and every one of them. We can have each of them introduce themselves as they come up. But I'll start out, then we'll pass it on to Kurt Sousa, Brian, Jing, Bob Holquist, and Saeed. So we'll let each person introduce themselves as they come up. Next slide, please. So for me, I'll start with my introduction. So my name is Randy Barnard. I am the chief of the technical operations section for Division of Drinking Water at the State Water Resources Control Board. I've been with the Division of Drinking Water for almost 20 years. Prior to that, I was in the Navy, and right after the Navy, I did some time as a consulting engineer before I started with the Division of Drinking Water. So I've been with DDW for almost 20 years now. And next slide, please. So I want to first thank all of you panel members for being a part of this historic task. Today, I'll be giving you just a short introduction and then quickly handing it over to the key members of our team to go into details with you about our draft DPR regulations. Now, when we had the first DPR expert panel a few years ago, I opened it up with a joke. And that panel process went really well. So just like most sports fans wear that same stinky sports shirt every time their team plays, just to make sure that that same good luck transfers over, I'm going to give you guys the same joke that I gave the other expert panel years ago. But I know Adam and Jim, they both like this one, so I'm sure it's going to be okay. So here we go. Next slide, please. So as I said, I spent 6 years in the Navy as a chemist on a nuclear-powered submarine before I started with DDW. Now, I want to start out today by telling you the most important thing to remember if you ever find yourself on a submarine. Next slide. This is what the toilet on a submarine looks like. Now, it doesn't flush like normal civilian toilets. After you've come and done what you've come to do, you lean face first over the bowl and you open the green valve to start filling the bowl with water. Then you have to pull that lever towards you to open the ball valve at the bottom of the bowl that lets all the contents drop into the sanitary tanks that are below. Then you shut both valves and you're done and you can walk away. Now, about once a day, those sanitary tanks get full. And the only way to discharge them overboard when you're underwater is to use high pressure air to blow them over. Now, the first step in the process is to hang signs on all the toilets that say blowing sands do not use. So here's my tip to you. No matter how tired you are after a long day on watch, always read the signs on the toilet, because nothing wakes you up faster than leaning your face over the bowl and pulling that lever, next slide, when they're blowing the sand tanks. Now, I never did it, but I saw it happen 3 times, and it was funny every single time. Next slide, please. All right, so I already feel the good luck starting to flow over into this meeting already from our last group. So the first topic I want to cover this morning is giving you a brief history of California's potable reuse development. That way, we're all working from the same understanding. Next slide. Now, you may recognize a few of these next slides because Jim stole my thunder, but that's okay. Now I can just skim over them a little bit faster. So Jim already talked about this slide, so I'm not going to go over it. But what I'd like to cover is just some very basics of each of these so that we can all get our bearings. Next slide, please. The first type of IPR is a groundwater recharge. The groundwater recharge regulations were adopted back in 2014, like Jim mentioned. There's 2 methods of application. You have surface spreading and injection. For surface spreading, as you see here, tertiary treated water is spread into a basin where it percolates down into the groundwater table, and then it has to spend several months there before it can be pumped out and used for drinking water. Next slide. The other method is injection. And this is where advanced treated water, and advanced treated means that it's been treated with reverse osmosis and an advanced oxidation process. And that's pumped directly into the aquifer. Now, it still has to spend several months underground, just like the spreading project, before it could be pumped out and used as drinking water. Now, there's around 10 or 11 of these permitted projects like this in California right now. And we have a couple dozen other ones in the works, in the pipeline, trying to get permitted. Next slide, please. Then we move to our other type of IPR project. It's surface water augmentation. We adopted these regs back in 2018. It's the placement of advanced treated recycled water. Again, that means RO'd and advanced oxidation with UV into a reservoir or a lake like this one you see here, used as a raw supply for a drinking water system. The mixed water would then be subject to further treatment by the downstream surface water treatment plant before being delivered to the public to be used as a drinking water. Right now, the city of San Diego is probably going to be the first project in California to use these regs, and they're going to come online in the next couple of years. Next slide, please. But the reason we're all here today is direct potable reuse, or DPR. The major difference between DPR and groundwater recharge or surface water augmentation is the environmental barrier. Well, the lack of an environmental barrier. And what I'm talking about is the lake or the groundwater basin that I just showed you. DPR projects do not have an effective environmental barrier, and some have no environmental barrier at all. So they have to compensate for that loss with extra treatment and monitoring to have an equivalent level of public health protection. Legislation is requiring us at DDW to have our DPR regulations adopted by the end of 2023. Next slide, please. But let's start with some simple graphics to show you what we think a DPR project may look like. The first DPR project is a raw water augmentation, which is supplying the treated recycled water upstream of a potable water treatment plant. It could be a very small reservoir that doesn't meet the surface water augmentation criteria like I just showed you in that other lake picture. The treatment failure here in this scenario could end up in the drinking water distribution system within a day. It just depends on the size of that natural reservoir. Next slide, please. Another form of raw water augmentation is that water going into a tank or constructed impoundment like this one. This is where there's no longer any contact with the environment at all. Here, a failure could make it into the system within hours. Next slide. Then we have the other form of DPR called treated water augmentation. Next slide. Which is when you get rid of the potable water treatment plant and supply the treated recycled water directly to the distribution system. Many people, and even Jim earlier, called this flange to flange or pipe to pipe. And it has a response time of only minutes for a failure to show up in the public drinking water system. Next slide. Now let's take a second to recap how we got here with our DPR regulations. Next slide. Back in 2010, Senate Bill 918 required that the State Department of Public Health, or DDW, investigate and report to the legislature on the feasibility, only the feasibility, of developing uniform water recycling criteria for DPR. And that was required by December 2016. Next slide. DDW convened and administered an expert panel, that was the first one we were talking about, and an advisory group to advise on scientific and technical matters regarding just the feasibility of developing regulations for DPR, and to make recommendations to us on any needed research that they could see. In 2016, that report to legislature from us stated, quote, "The State Water Board found that more research will make a significant contribution to the development of criteria for DPR. And most importantly, will provide a higher level of certainty that the criteria are protective of public health." Next slide. Then in 2017, Assembly Bill 574 was enacted. It required us at DDW to adopt uniform criteria for the first type of DPR that we talked about, which was raw water augmentation. And that was required to be done by December 2023. That bill also required another expert panel, which is you guys, to make a finding that the draft criteria would be protective of public health. And it also recommended that we develop a framework for DPR before we even start to draft the regulations. Next slide. So first things first, in 2017, DDW developed the research questions and scope for some DPR research projects. The State Water Board started working with the Water Research Foundation to develop the DPR research projects that Jim talked about. And we started to help direct and administer those projects. So I mentioned research. What research are we talking about? Well, the State Board felt the research recommended by the first expert panel was important, and it's listed here. that it was important to do this before adopting a DPR criteria. We helped fund the research, and it's been completed at the beginning of this year. Now, there was a source control study. There was DPR Project 1, which is the QMRA, DPR 2, which is the raw water pathogens. Then we did a worst case raw pathogen levels, basically an outbreak study. Then we looked at reduced chemical spikes. And then the last study was the analytical methods for unknown low molecular weight chemicals, or unknown unknowns. And I'm not going to go into detail about this research. Some of it's going to be talked about later by Brian Pexon. But there are presentations that we could send to you that we have done in the past on all of these. So if you're interested, let us know. We can send those. But basically, all of these research projects can be encompassed by, it covers our assumptions, the treatment, and monitoring questions around DPR that were raised in our prior feasibility report. Next slide, please. Now, like I said a minute ago, Assembly Bill 574 also required us to develop a framework document before we ever started to develop the regulations. Next slide. So we did, and we finished it in 2018. That document contained the board's thinking on how we could regulate DPR, and it gave transparency and provided a vehicle for stakeholder outreach and comments. Now, based on that feedback we received, we updated the framework in 2019. And based on an extensive evaluation, and after contemplating all the stakeholder feedback, we determined that we could develop a single regulation package with criteria that encompassed the range of DPR scenarios and still provided protection of public health. And we could do it all by December 2023. So to answer Mike's question a little bit earlier on why we're doing all one package, a lot of that is specified in this framework document. So we can supply that to you also so you can see it. Next slide. Now that brings us all the way up to today. We have all the research done. We completed our first draft of the DPR criteria. We had it peer reviewed, and then we posted it on the website as the framework addendum and included a bunch of our rationale on why we stated what we stated. We've also made some updates based on the comments we received back from the peer reviewers and from the public comment period. And now it's all with you to verify that it's protective of public health. Next slide, please. Now, the last segment I'm going to talk about is a brief overview of how regulations are adopted, what the process is, and how you, as the expert panel, fit into that process. Next slide. All regulations follow a similar adoption path. The major steps are inspiration, or time when the need for regulation is defined. Then there's the regulatory package development. That's the step we're in right now. So we're only in step 2. Then after that is the formal regulation adoption process, which is outlined in the picture you see here. And then we fall into implementation of the regulation. If you look at the graphic, where we're at is we're at the very first top green arrow that's turning. We're getting the reg package all together and the reg language complete before we start the formal adoption process. Now, that adoption process follows the APA, or the Administrative Procedures Act process, and it will include future public hearings and some formal public comment periods. Next slide. Now, in the reg development phase, which again is the phase we're in right now, there's many steps. One major step is developing the regulation text. Now, that step can be broken down into a few key milestones, like, for instance, finishing the reg text, which we've done. We wrote the draft. Then having that text go through a peer review process, which we've also done. We sent that out to have peer reviews take a look at it, and they sent their comments back. And because it's required by statute for DPR, we have to have an expert panel review the language, which is what we're doing now with you guys. Next slide, please. Now, the scientific review process, which we've already finished, is required by the Health and Safety Code. The peer reviewers we're checking to make sure that key assumptions in our regulations were scientifically sound. Next slide. Now, going through an expert panel review is not normally part of an APA process. Like I said earlier, the legislature in AB 574 required that an expert panel review our draft criteria and adopt a finding whether, in its expert opinion, the draft criteria could adequately protect public health. We at DDW cannot adopt these regulations until you're finding that you find it's protective of public health. Now, we're looking for you to reach a consensus and provide a memo to us at the state board around mid-2022 regarding your finding if it's protective or not of public health. Once we get that memo and it's found to be protective, then we can put the whole DPR reg package together and begin the formal APA adoption process. Next slide. This slide shows you a simplified version of what that formal process looks like. And you can see here, there are many reviews that it has to go through, and there are going to be a couple opportunities for formal public comment periods after you and the expert panel make your findings. Next slide. Now, to wrap up my part of the presentation, here's a timeline for us if we want to get the DPR regulations done by the statutory mandate. And so I'll leave that so that you guys can refer back to it. Now, with that, I'd like to turn this over to our next presenter, which is Kurt Sousa.
Hello, everyone. Can you hear me all right?
Kurt, we can hear you.
All right, great. Thank you. I'm Kurt Sousa. I'm the Southern California branch chief of the Division of Drinking Water. I've been with the division in a field operations branch for just over 30 years now. Actually started as a student right out of college, in college, and then right out of college. So I'm kind of one of those field guys that like to poke around water treatment plants for a living. Next slide. I'm going to discuss how the Safe Drinking Water Act and our current drinking water program kind of fits in with these DPR projects. So since direct potable reuse projects will supply a water treatment plant, to be directly discharged into a public water system, I'd like to provide a brief overview of existing drinking water regulations and regulations that would apply to a DPR project in addition to what you're looking at with specific DPR regs. Next slide. The California Safe Drinking Water Act implements the federal Safe Drinking Water Act, but the California legislature intends for regulations to go beyond the minimum requirements of the federal Safe Drinking Water Act at times to reduce concentrations of toxic chemicals in drinking water that may cause cancer, birth defects, and other chronic diseases. So back in the mid-'80s, it was the Budget Act of 1985 gave the drinking water program a standard setting program. And since then, we've been writing our own regulations. Some are review of federal MCLs, which we accept or we can lower based upon our own risk assessments, and some for chemicals that the federal government does not regulate, such as perchlorate, where we develop our own standards. Next slide. The California Safe Drinking Water Act applies to public water systems, and the Health and Safety Code defines what a public water system is. A public water system includes the collection, treatment, storage, and distribution facilities used in the provision of drinking water, but may also include facilities upstream of a public water system that are not under the direct control of a system. And that's number 2 on the slide. A water system provides treatment on behalf of one or more public water systems to render water safe for human consumption is also a public water system. And that'd be kind of like a wholesale system, which would provide treated water to cities and stuff. Because DPR is a system that for the provision of water for human consumption through pipes or other constructed conveyances, it would be a public water system. And I'll talk about it a little later, but it would also receive a Division of Drinking Water permit. And to go back to number 2, which is something that's always interesting, and this happens a lot now, for like a surface water treatment plant and a system that serves surface water, a lot of times they pull from a lake, which is not owned, operated, or controlled by the water system. But through the drinking water supply permit, a recreation plan for the reservoir lake and also land use around it, we would work with counties, say, U.S. Forest Service, landowners, to protect the source as much as possible through our permit provisions through the public water system. And we wouldn't be regulating it directly, but we do have some indirect control or suggestions or whatever you want to call it to help keep that water as safe as possible. Next slide. The Health and Safety Code prohibits public water systems from operating without a permit. Sources of drinking water must therefore be reviewed and approved prior to use. Most sources approved in California are conventional sources, such as groundwater or surface water. However, some sources of water proposed by public water systems are highly contaminated, and the drinking water program has determined that increased scrutiny is needed to ensure the protection of public health. These sources are called extremely impaired sources, where we have some information on our website about it. The wastewater source used for DPR is considered an extremely impaired source, and AB 574 has required the drinking water program to develop regulations for the use of this type of specific source. Next slide. Public water systems must operate in compliance with their operating permits. So every water system has a permit, and they are subject to sanitary surveys, routine sanitary surveys, which are every 1 to 3 years, and other inspections depending on what's going on at the system and the treatment facilities. Similarly, DPR projects will be permitted by the drinking water program and must comply with the regulations, permits, the permit provisions, which I'll talk about in a little bit, and directives included in any kind of enforcement action or compliance order that is received by the water system. Routine oversight, including the sanitary surveys, inspections, submittals of monthly compliance reports, and develops of various types of plans outlined in the DPR draft criteria and other plans that public water systems have, such as emergency notification plans and emergency response plans, would also be reviewed and permitted by the drinking water program. Next slide. In the California regs, there's various drinking water standards. The drinking water supplied by the public water systems must comply with all the MCLs, action levels, and treatment techniques, which are listed here. And as you can see here, that there are 13 California-only specific chemical MCLs, and there are 25 chemicals that are regulated in California at a more stringent level than the EPA federal MCLs. Next slide. In addition to just standard water quality limits or MCLs, drinking water regulation also limit contaminants by using a combination of monitoring and treatment technique and or MCLs in standards that are listed here, like the total coliform rule, groundwater rule, surface water treatment rule, lead and copper rule, and the disinfection byproduct rule. And just to note that the DPR regulations, the proposed regulations, will be part of the surface water treatment rule. There will be a section within the surface water treatment rule. Next slide. DDW has set health-based advisory levels, or what we now call notification levels, since the early 1980s. Generally, notification levels have been established in response to an actual contamination of a drinking water supply, like perchlorate, and also 1,4-dioxane and NDMA. And some are now MCLs, like perchlorate. We now have a perchlorate MCL. However, notification levels for a number of chemicals were established in anticipation of possible contamination from hazardous waste sites or Superfund sites where drinking water sources were near it. And we thought maybe, some of these chemicals would come over. And to date, notification levels have been established for 96 chemicals, 40 of which have then turned into MCLs, and 32 of which are still active notification levels, and 24 we've archived. We just don't seem to need them anymore. Next slide. Monitoring of sources is used to determine compliance with the MCL. And if a source does not meet the drinking water quality standard, it must obviously provide some kind of treatment. An assessment of the vulnerability of the source to possible contaminating activities is done, either by conducting a watershed sanitary survey for a surface water source or a source water assessment for a groundwater source. Division of Drinking Water reviews the information submitted by the public water system and then determines the monitoring on a case-by-case basis. And a lot of times monitoring of sources that are near potential contaminating activities, we could increase the monitoring from every 3 years to every year, or every year to every quarter, or whatever we feel is necessary based upon the information that is provided. And those decisions are made on a case-by-case basis based upon the information we get and are put in the permit. So the last slide, my last slide, are other requirements. Since DPR facilities will be permitted as a public water system, other requirements of a public water system would include like operator certification, could include cross-connection control programs, waterworks standards, the public notification rule, how and you will notify your public, the production of a consumer confidence report every year, and permit provisions. So the last one is permit provisions, and I wanted to just pause there for 1 second. Every water system gets a permit, and permit provisions are provided in the permit, which are essentially required by the water system and can be cited if they don't comply with the provisions. And they are above and beyond the regulations, and they are for specific conditions at a certain facility, and they are done on a case-by-case basis. So an example, let's say you got a GAC facility that's treating for a contaminant, say TCE. And let's say it's a lead lag facility. So you have two, it goes through the lead vessel, then it goes through the lag vessel. The regulations just say you have to sample the effluent going into the distribution system monthly. Well, that's not really good enough to operate a facility like that. So within the permit, we require monitoring between the two vessels. So there'll be a monthly effluent monitoring, which is per the regulations, but there would also be a permit provision that required monitoring between the lead and the lag vessel to determine when the chemicals go through the first vessel. And then if the chemical starts to go into the lag vessel, we would switch that intermediate monitoring, and this would all be laid out in the permit to say 25% monitoring, port monitoring, or 50% port monitoring. And then eventually the water system would change out the GAC, either just change out the lead vessel and switch the vessels, or change out both. All of that is discussed with the public water system, how they want to operate the treatment facility, and then a sampling schedule is determined and then put in the permit as a permit provision. So a lot of water systems have such items, and a DPR system would obviously have a lot of permit provisions, which would require monitoring within the treatment process that would not specifically be part of the regulation. It would be based upon their specific treatment process. So that's all I have, and thank you for the time.
Well, thanks, Kurt. Randy, who's up next? I think we got Jing. Take it away.
All righty. Hi. Can you hear me?
Yes, we can hear you, Jing.
Okay, good. All right, so my name is Jing Chao. I'm an engineer with the Division of Drinking Water. I've been here for about a little over 20 years, 15 of which were in the field, doing permits and inspections for Riverside District. So I've since moved on over to the technical operations section to work specifically on the DPR regulations. That's my own slides. All right, so the State Board is presenting the proposed DPR criteria to the expert panel pursuant to the legislative mandate in AB 574. We are requesting that the panel review the proposed criteria and make a finding as to whether, in its expert opinion, the proposed criteria is protective of public health. So this proposed criteria has these 27 sections shown. We'll go over them briefly, but focusing mainly on the pathogen control and chemical control sections. Bob Colquist and Saeed Hafez Nizami will present the pathogen control section in detail this afternoon, and Brian Bernadas will present the chemical control sections in detail tomorrow. So to begin, let's cover the guiding principles for the development of the draft criteria. So these are discussed in detail in the framework documents we posted back in 2018 and 19. The draft criteria must be able to produce safe drinking water meeting a daily risk objective not to exceed 2.7 times 10 to the negative 7, which is the 10 to the minus 4th annual risk of infection divided by 365. The treated water must meet drinking water standards, and peaks of chemical concentrations known to occur through a potable reuse treatment must be addressed. Also, unknown chemicals in the water must be reduced to levels that are below public health concern. As recommended by the 2016 DPR Feasibility Expert Panel and the 2019 Source Control Expert Panel and others, the draft criteria features multiple barriers for chemical control, multiple barrier log reduction requirements for pathogens, robust treatment using varied mechanisms, source control for contaminant reduction and prevention, extensive process monitoring using accurate real-time information, continuous monitoring, alarms, automatic diversion, and the application of a critical control point approach. Lastly, due to the proximity of the wastewater to drinking water with DPR, the response to a failure must be for the process to fail safe, meaning that the response to a failure must involve the transition to a safe condition. In this case, for the process to halt the production of drinking water and for the procedures to be implemented to identify and correct the fault and restart the process per an improved startup procedure. Establishing the legal authorities, roles, and responsibilities in the structure of the overall organization of the DPR project is foundational to the ensuring safe drinking water. A cohesive organization for a DPR project is necessary for the project to succeed. So in our regulations, section 64669.15a, we require that we define the DPR as the agency responsible for complying with the criteria. We require that only one DPR shall be designated for a DPR project. And the DPR must be a public water system and must obtain a water supply permit. And the DPR must submit a joint plan that describes the partner agencies involved in the DPR project, the roles and responsibilities of all involved in the project, the legal authority of each agency to fulfill its role, and the overall organizational structure involved in implementing the joint plan. So the joint plan describes how the managing of the DPR project is organized. It is a plan developed by the DPR, operating within the agreements with partner agencies that allows it to ensure that the DPR has current knowledge of the status of treatment of the entire DPR project. Take corrective actions if water delivered from a treatment facility fails to meet the treatment or water quality requirements of the article. Implement source control requirements pursuant to the source control section 64669.40, including provisions to conduct source control investigations, and optimize corrosion control to reduce lead and copper levels in the distribution system. Provide notification of partner agencies and the State Board of operational changes that may adversely affect the quality of water delivered by the treatment facility. Provide customer notification pursuant to the sections that require it, and we also receive customer complaints pursuant to the section that requires it. Provide an alternative source of domestic water supply or drinking water if the DPR project is unable to supply water. And the joint plan must be up to date. So we have some requirements for the joint plan to be resubmitted when particular events occur. So we include a technical, managerial, and financial capacity requirement in the draft criteria. So prior to the operation of a DPR project, all participating agencies in the joint plan involved in wastewater collection, treatment, monitoring, or control of the DPR project prior to finished water distribution shall demonstrate to the State Board that the agencies possess adequate technical, managerial, and financial capacity to assure compliance with this article. So one portion of the demonstration shown here, there are other criteria in the draft. So the engineering report must describe in detail the facilities, staffing, and support services necessary to comply with the regulations and continuously produce safe drinking water. The engineering report must specify elements that have costs associated with it, such as operations and maintenance costs, 20-year life cycle costs of equipment, capital replacement costs, energy costs, personnel costs, etc. The engineering report must identify reliable and continuing funding sources for the necessary costs associated with the annual operations and maintenance, capital replacements, and an annual capital budget. So moving on to regulated chemical monitoring. This table summarizes the chemical monitoring requirements in the draft. So monitoring at 3 locations is specified. Monitoring at the wastewater that feeds the DPR project, and depending on the project, which could be tertiary recycled water, could be secondary, or even raw wastewater. A2 specifies monitoring of the advanced treated water immediately after the advanced oxidation process. And lastly, A3 talks about the finished water prior to the entry point to the distribution system. So the DPR will propose the sampling locations for the project. When a sample shows an MCL is exceeded, the requirement is to collect a confirmation sample within 24 hours of notification by the lab. If the sample is confirmed to exceed MCL, various actions will need to take place, including increasing the sampling frequency, evaluating the treatment system, initiating a source control investigation, notifying the State Board, or notifying public water systems, governing bodies, and the public, and also diverting flow in some cases. So this table has this little legend at the bottom with a different color coding of actions that are taken at the various sampling points for various conditions. So I want to note that we received public comments suggesting that different monitoring and compliance requirements should be established for raw water augmentation and treated water augmentation. And I should note that it is already a framework that we've put out there in the draft. So a DPR may establish an entry point sampling location downstream of a blend point that is representative of the finished water being distributed, for example, and a large water reservoir or finished a large raw water reservoir or finished water storage may dampen the concentration of any chemical peaks and provide a margin of safety from exceeding an MCL at the A3 sampling point, for example. All right, the draft also includes a section on monitoring unregulated chemicals. So the monitoring is going to be proposed at the same locations as the regulated chemical monitoring for the following chemicals that's not otherwise listed in the regulated monitoring section, which includes priority toxic pollutants specified by the State Board based on our review of the DPR project engineering report, contaminants with notification levels, contaminants specified by the state board based on its review of the engineering report and findings from source control investigations or assessments that were performed. And we also include monitoring for solvents, acetone, and dimethyl acetamide, methanol, and methyl ketone. And these are, I believe, the small molecular weight compounds that's likely to go through advanced treatment. And we also require monitoring of treatment byproducts and the precursors. So in section 64669.65 G and H, we have a couple other more monitoring of unregulated chemicals. And these are from industrial sources identified in the source control section. Chemicals that could be from businesses, household sources of hazardous substances, most prescribed pharmaceuticals, and personal care products based on analysis of wastewater and environmental water sampled locally. So this is a review of studies that's going on, or sampling information from their own wastewater treatment plant that may show the occurrence of these chemicals. And also the project needs to sample for chemicals known to the state pursuant to the Safe Drinking Water and Toxic Enforcement Act of 1986. So the chemicals that cause cancer or reproductive toxicity, you should monitor for those. And chemicals likely to be present in wastewater used in a DPR project based on reviews of possible contaminating activities identified in drinking water source assessments performed by or for the DPR or the partner agencies involved in the joint plan. The reviews of chemicals of emerging concern in wastewater, including endocrine disrupting chemicals that may be in reports from state water board advisory bodies in the scientific literature, and list of most prescribed pharmaceuticals. And then I talked a little bit about the monitoring of unregulated chemicals. What happens when you detect of a chemical with a notification level. And it's kind of similar to the framework we established for the regulated contaminants, which is to collect confirmation sample, increase monitoring to weekly, conduct an evaluation of the treatment system, initiate a source control investigation for the approved joint plan, submit results to the state board in a monthly compliance report. And after they've done this and done the investigation, the DPR may apply to the state board to resume the monthly sampling after submitting a report summarizing the evaluations and their findings. And then if they detect a chemical with a notification level at the A3 sampling location, which is the entry point to the distribution system, they need to report the results in the consumer confidence report. If they exceed the notification level, you follow the same procedures as the NL detects. You plus notify the state board, local governing bodies, partner agencies, and public water systems receiving the DPR project water. And when you exceed the response levels, we notify the state board and follow the applicable requirements in the health and safety code sections that address notification levels. And I believe 116378 is the one that one of these talks about the PFAS specifically. So for this type of monitoring for unregulated chemicals, you can reduce the monitoring frequency to quarterly, and then also reduce or waive monitoring for chemicals after 2 years of non-detect results. All right, moving on to alternatives. So we kept a alternative section in the DPR draft, which is similar to the IPR, surface water augmentation regulation. The alternative section allows for treatment innovation while requiring the alternative to demonstrate an equivalent level of public health protection. Alternatives are not allowed for requirements that set the standard for public health protection, such as requirements for the number of treatment mechanisms and number of minimum number of barriers. So in the alternative section, we require that chemical treatment alternative trains must use 3 different treatment mechanisms with a required separation mechanism, for example. So you must use a validated technology or technology that you validate, or conduct a demonstration study to demonstrate treatment efficacy. Based on feedback from the public, we added detail to around demonstrating chemical treatment alternatives. And the criteria includes requirement for a water safety plan. So the water safety plan for the DPR project must be developed to identify risk management controls beyond what is specified by the regulations as a precaution against unaddressed site-specific hazards, and must be updated every 5 years. And an independent advisory panel will review and provide recommendations on whether all hazards have been considered by the DPR. And the DPR shall consider the recommendations of the independent advisory panel on proposed revisions to the water safety plan. And these could be things that we were thinking about when we were developing this is, maybe in a community or a project, there is a particular, industry of concern, or in the future when we find new pathogens of concern. And so, we don't have to wait for our regulation to be updated for a project to do the analysis to protect itself and for the DPR project to continue to provide safe water. So this water safety plan is to look at anything else that could be a threat or a hazard to a particular project now in the future. So since we have a few minutes, I would like to address comments we received during the public comment period requesting further clarification of the distinction in the proposed criteria between raw water and treated water augmentation. So, we talked about this, at least internally within our work group about this because, AB 574 requires us to adopt regulation for raw water augmentation. And, in the second edition of the framework document, we let everyone know that we're considering a single regulation package. But, even as we're developing a regulation package, we were thinking about this and, we came to the decision that there is no property of raw water augmentation that's uniquely raw water augmentation for all scenarios. And there's no property of raw water augmentation that can only be applied to raw water augmentation, not treated water, except for the existence of a water treatment plant. The presence of a water treatment plant is the only distinction. So, however, the treatment plant may be simply a chlorination station or a GAC filter. So the statutory definition does not specify it to be a surface water treatment plant. And I believe, many commenters, you guys operate surface water treatment plants. So that's, what you're thinking. But we're writing a regulation that is uniform criteria that will apply to statewide, and it may not be the situation in every project that might want to propose DPR. So, we considered, a treated water augmentation project that has a large finished storage reservoir that may provide a longer response time than for example, a raw water project with a very small surface water treatment plant. So, if you look at those two projects, you might say that the treated water augmentation project will provide a longer response time than this other project. So it's not because, the distinction is that the raw water augmentation project is necessarily, better, than treated water or safer under that scenario. And then you can also consider a treated water augmentation project with a reliable source of blend water that's, from a conventional source that's approved by DDW versus a raw water augmentation project with no intermittent source of blend water. So these point to the direction that we followed in developing the criteria. So we account for the features that may provide benefits, regardless of whether the project is treated water or raw water, which include blending, mixing, and response time, as several commenters pointed out. So for blending, the framework document first edition provided a proposed distinction between raw water and treated water, and it's based on the criteria that a water treatment plant is a surface water treatment plant, and that there is a meaningful blend with other water. So the meaningful blend that we were proposing was a 9-to-1 blend of an improved source of water with municipal wastewater. And then based on the public comments we received, we made revisions to the chemical peak requirements, which Brian Bernos will go into detail tomorrow. So these include the ozone BAC equivalent for a blend and a 0.5 TOC limit allowance for a blend or a project with a blend. So more to come on that. So on mixing, mixing is when treated water is mixed with previously treated water, as with the surface water augmentation regulations. So the mixing does not provide pathogen log reduction, as it is just mixing, stirring at the water. But mixing can attenuate a chemical peak, and the draft criteria incorporates longitudinal mixing as a component of the chemical peak requirements. However, that requirement applies to both raw water augmentation and treated water augmentation projects. A DPR project that has mixing capacity beyond that specified in the subsection K can propose it as an alternative chemical treatment using the alternative section. In terms of response time, so between the DPR project intake and the entry point to the distribution system, sufficient time must elapse to allow for the identification of a treatment failure and diversion of flow to protect public from exposure to inadequately treated water. So in the section 64669.85J, it talks about this, and the project needs to make a calculation and determine what that response time is for the project. So it is already incorporated into the draft criteria. Finally, we had comments on the role of surface water treatment plant. So the role of the surface water treatment plant for pathogen reduction treatment, in the criteria, we say that the treatment process must be validated. Draft language has been added to clarify that validation can be done at the pilot scale, and that previously validated membrane filters do not need to be revalidated. The disinfection process at a surface water treatment plant that was previously validated may be credited using the existing surface water treatment rule frameworks without additional validation. And I want to note that a satellite treatment plant that provides pathogen credit, the plant control system communications feed must be shared with DPR, since the DPR will need to have the current knowledge of the status of treatment for the entire DPR project. So in other words, the DPR SCADA system must track everything that it is getting credit for. The surface water treatment plant becomes integrated into the DPR project train and may not be wholly independent. All right, I think that's the last slide I have. I don't have a question slide, but any questions in the time we have left before lunch?
Yeah, let's bring in the chairs and the panelists here real quick, Jing. And Jim and Adam. Yeah, my clock says we've got about 5 minutes before the top of the hour. I guess we got a couple options. We could ask them to use this time to start questions, or we could take a break and start earlier next time and reserve more time at the end of the day. There's probably another approach I haven't thought about, but I'd like to move forward based on your preference.
There are a couple questions I know that some of the panel members have, and it might be worth jumping in and just asking them now if they wish to, or they could hold off. I'm open for either. How about you? You as well, Jim?
Oh, there it is. Yeah, I agree with you, Adam. I think it's like.
So if a panel member has something that they'd like some clarification on, just let's ask it.
I see, Doc. Yeah, go ahead, Chuck.
Okay, I'll start out with one for Randy. So the treated water augmentation, I just want to clarify the definition. So in the pipe-to-pipe version of that, does that of necessity imply that there will always be a second source of water entering to that distribution system?
Well, and Jen can jump in on this with the exact definition, but I don't believe the definition specifies that there has to be a second source of water. But operationally, I believe there's going to have to be, because a community is not going to be able to rely on solely its wastewater. It's going to have some other source in addition.
Well, if there's not, then the word augmentation is a bit misleading.
Right. Well, we're just going off the definition that the legislature gave us. We didn't come up with it.
Okay, understood.
I just have a quick question. Is the difference between the RWA and the TWA, does that mean in the RWA that the monitoring will be post drinking water treatment or before, or both? Compliance monitoring.
Yeah, so we established 3 points, and then one is the raw, one is right after advanced treatment, and one is prior to entry point. So the DPR can work with, if the DPR is serving the water directly, yeah, it'll be, before it gets into the distribution system at a sampling point that's representative.
I don't quite understand. I still don't understand. I'm asking the question. It seems that the assumption would be that the waters are equivalent after the drinking water treatment plant in the case of RWA to the TWA. So that seems to be where if you're going to compare them, that's where you compare them.
Yeah, well, it depends on this what's happening at the surface water treatment plant, because the surface water treatment plant could be accepting other waters in addition to the DPR water.
It still seems to be a hole there.
Yeah. Okay. Yeah. Just let us know what the comment is. So there could always be additional monitoring that's levied, but these are the minimum 3 that we specify. And as Kurt pointed out before, we can, if need be, and there's holes in monitoring that can always be filled through permit.
Okay. And Jane, that would occur through the permit conditions element, right?
Right.
Yeah. Dick, did we answer your question?
I'm not quite sure, but let's don't prolong it. We'll bring it up later.
Yeah, good. Okay, we'll put that into the comments and see where it takes us. Yeah, we're right up on the hour. Any other questions again that we can get to? We think we want to get to now from the panel. Not seeing any. And again, without anybody raising their hand or having their camera up, I'll make the assumption that your questions for now have been answered. The agenda calls for us to come back at 12:30 when we're going to hear from Brian Pexon, who is the PI on DPRs 1 and 2 that you heard about during the course of the morning. Brian's a really gifted speaker, and he's got a deep dive into those 2 projects. So let's now take a break at 12. We'll reconvene on schedule at 12:30. We'll hear from Brian and conclude with the rest of the day's agenda. Thanks. We'll see you in a few minutes.
Thanks, Kevin.
Well, welcome back. I've got 12:30 on my clock, and we've got a busy afternoon, so let's get underway. Kind of reflecting back in the morning, and we've kind of gotten through our first objective, which was to go over the process, do a little bit of introductions of each of all the players here that are working together, and look at the schedule for this project. And we're working now on our second objective, which is to build that kind of baseline overview level understanding of the work that's been done and how we got here. And so to take a deep dive on 2 of the critical DPR research projects that we heard about this morning is Brian Pexon. Brian is an associate of Trussell Technology, has both masters and PhDs from UC Berkeley. Is also Marie Curie postdoctoral fellow at AVOD, the Swiss Federal Institute of Technology, and a Fulbright fellow. So very honored to have Brian here today to present and give us an overview of what we learned in DPR 1 and 2. Brian, take it away.
Thanks, Kevin. Good afternoon, everybody. I'm Brian Pex, and I served as the PI for 2 of the 3 pathogen-related projects that the state board sponsored for DPR regulatory development. So today I'm going to walk you through the motivation for those projects, the scope of the research we did, and our findings and recommendations. So next slide. A key to any drinking water regulation is understanding how much protection we need to provide against pathogens, because they can cause infection and illness after even just a single exposure. They're the most important aspect of public health protection. So we make the water fit to drink by specifying treatment requirements. The concept is easy. There are pathogens at high concentration in raw wastewater, and we need low concentrations in our treated drinking water. So we provide treatment to bridge this gap from high to low. As we know, the draft criteria specify 20 logs of virus reduction, 14 of Giardia, and 15 of crypto. And while I'm illustrating this as a simple linear calculation, next slide, it's actually not that simple. This image on the side shows some of the multiple steps involved in the process of risk assessment. Remember, we're using this process to identify DPR treatment requirements, but we know that it's going to vary depending on things like which pathogens we care about, which lab methods we use to enumerate them, how much water people drink, the likelihood that that exposure leads to an infection, and finally, what level of risk is acceptable in our population. Next slide. And that's where the DPR1 project fits in. It was pursued to create a consistent and transparent framework to do 2 things. 1, to determine the level of treatment that's needed to adequately protect public health, and 2, to assess the performance of DPR treatment facilities. So this link between risk and treatment is important because California is developing risk-based treatment requirements that are in line with our other potable water regulations. Next slide. DPR1 was led by a technical work group, including Professor Haas, who's on the expert panel, along with Nick Ashbolt, Terry Slifko. The main product of this work was a web-based tool to evaluate treatment and risk, and this effort was led by our excellent research team, Dan Garrity and Edmund Sato. Finally, we also had significant support from Anya Kaufman and Adam Livieri, who served as the coordinator between the technical work group, the Water Research Foundation, and the state board. Next slide. When we look at which of these inputs has the largest impact on the treatment requirements, perhaps the largest is, next slide, what we assume are the concentrations of pathogens in raw wastewater. We have higher raw wastewater numbers, that means higher levels of treatment are needed, and vice versa. So pinning this down is critical. And that's where the DPR2 project fits in. Next slide. This project originated from the fact that we don't currently have sufficient high quality data on this topic. So our first goal was to collect a new large data set characterizing the distributions of multiple pathogens. One of the reasons we didn't have better data prior to this project was due to the challenges of measuring pathogens in a matrix like raw wastewater. So the second goal was to develop recommendations for collecting and analyzing data that overcome some of the previous limitations. Next slide. Like DPR1, DPR2 was organized around a TWG shown here on the top, George, Menu, Cara, Chana, Terry. We had 3 commercial laboratories process the raw wastewater samples. In addition to their own QA/QC, all of these results were then reviewed by our independent QA/QC officer, Walt Jakubowski. We also had significant contribution from Emily Darby and Adam Livieri, who again served as the liaison with WRF and the state board. Next slide. We started with a lit review to see how many studies had been done, what data we could leverage, and to identify any of the shortcomings in these studies to try to fix in our own standard operating procedures. So when we set up filters to look for high quality studies, we identified only a handful of relevant examples. These are roughly bookended on one end by Joan Rose's seminal 2004 study, and on the other by 2 recent studies in San Diego County supporting pure water projects. One issue that we saw was low method sensitivity, leading to high frequencies of non-detects. And so on the figure on the right, I'm showing 10 crypto distributions from the literature. You can see that many of these distributions start only at the 25th percentile or higher, meaning that 25 to 50% of the samples were non-detects. So this is one area we wanted to improve. We also noted that recovery efficiency was often not measured, so there's no correction of the data for losses. Finally, we also saw inconsistent use of standard method controls. So we concluded that while it is in fact possible to measure pathogens in raw wastewater, the existing amount and quality of data are insufficient. Next slide. Based on these findings, we conducted method optimization to address the limitations of these previous studies. This included optimizing concentration methods and the amount of sample to process in order to consistently get detectable values. We also specified rigorous QA/QC, including matrix spikes that we used to assess recovery in 75% of all of our samples, along with running a full suite of controls on each sample. So one of the big themes of this project has been the importance of data quality. Along these lines, we recommend the use of the DPR2 Quality Assurance Project Plan, QAPP, shown here on the right, for future pathogen studies. Next slide. For the sampling campaign, we selected Giardia, crypto, and enterovirus in line with the surface water treatment rule in California's IPR regs. We extended virus monitoring to also include adenovirus, norovirus, and SARS-CoV-2. We measured these viruses with both culture and molecular techniques as shown. To develop the new data set, we conducted a 14-month pathogen monitoring campaign, collected samples at 5 facilities that are either currently engaged in potable reuse or are pursuing it. So with 24 samples collected at each facility, we developed an extensive 120-point data set for each of these pathogens. These samples were collected at facilities across California, covering a range of flows from 30 to 275 million gallons per day. All told, this campaign sampled the wastewater of approximately 1/3 of the population of California. Next slide. So let's dive in and look at some of the data. In this case, the cryptosporidium distribution. This distribution shows the log concentration on the y-axis, and any point on the line tells you the probability of getting a concentration at or below that value. So in this case, the median concentration is about 2, which means 10 to the 2 or 100 oocysts per liter. Next slide. What you can see right away from this distribution is that we achieved a high rate of detects across the entire range. And this is a reflection of the high sensitivity of the methods. This fact that the data set has quantifiable values at both the high end and the low end of the distribution. For the microscopy and culture-based methods, 91% of those samples were above the limit of quantification. So I'm showing here with this circle that we don't get to see the low end of the distribution as well as the high end, but we still get clarity down to very low percentiles. Want to note we had lower detection rates for the molecular assays because we couldn't concentrate those samples as much as we could for other assays. Next slide. Because we ran matrix spikes on all the protozoa samples and half of the virus samples, we could correct all of the concentrations for losses. These matrix spikes also showed us that we had a high and consistent efficiency of recovery. For example, we had a recovery of at least 10% in more than 98% of all of our assays. Next slide. We also wanted to see if the distributions could be well described by models. The benefit of this is that we can use the models then to estimate the probability of getting concentrations outside of the range of the values that we measured. Luckily, we found that the pathogen distributions were in fact well described by log 10 normal distributions. Next slide. Finally, we could also compare these distributions to the point estimates that were previously used to develop the IPR regs. In this case, you can see that the crypto distribution did not reach the 10 to the 4th value used for IPR before the 99th percentile. We could, however, use our distributions to estimate the probability of reaching this concentration, and we would do this at the 99.999th percentile. Next slide. Based on these findings, the TWG recommended that the state board use the model distributions as raw wastewater inputs. These distributions are critical for doing the probabilistic assessments that were recommended by the 2016 expert panel and that were also developed in DPR1. Next slide. Here's some of the other key findings from the TWG's analysis of the data. We evaluated the impact of different locations by comparing the distributions across the 5 treatment plants. We found a high degree of similarity, with 94% of the comparisons having no significant differences across facilities. We also found a minimal impact of seasonality when we compared summer months to winter months. Some pathogens that did show trends included higher enterovirus concentrations and lower adenovirus concentrations in summer. One important external factor was the presence of the COVID-19 pandemic during 2/3 of the monitoring campaign. We evaluated the concentrations in the 4 months prior to the stay-at-home order against the 10 months after to begin to assess this impact. And generally, we didn't see a clear impact on the numbers. Most of the distributions didn't show a statistical decrease after March of 2020. I want to note that it's clear that this public health intervention was important for controlling the spread of respiratory diseases in California, but the impact on gastrointestinal infections was not evident in the data that we collected. Finally, we developed some new information that adds to the uncertainty in the use of molecular data. So let's go to the next slide. Molecular methods like PCR measure the genomic material of a virus directly, which offers a number of benefits. One thing it can't do is tell us if that genome copy is associated with an infective virus. For example, a virus could be damaged in a way that makes it inactivated, but leaves its genome entirely or mostly intact. As a result, it's not straightforward to do this translation then between the number of genome copies you measure and the number of infective viruses. The DPR2 data set provides us with some new insights into these ratios because we measured 2 of the viruses with both methods. In this figure on the right, we've plotted a distribution of the ratio of genome copies to infectious units. And what I'm showing is the log of this ratio for enterovirus at all 5 facilities. What we see is at the low end, this ratio can be as low as 1:1 or 10:1, but at the high end can go up to 10,000 to 1. I'm not showing the adenovirus data, but we see even larger ranges there with highs up to 100,000 to 1. So I want to emphasize that these ratios were reproduced at multiple facilities with 2 independent labs, supporting the belief that this variability is a real and important phenomenon. Next slide. Why are we spending time with this? Well, for some pathogens, we don't have culture methods, which is the case for norovirus, which is one of our most important public health viruses. We can still, however, collect information on the number of genome copies present using PCR. And that's what I'm showing here on the right side. The DPR2 data are the black data set on the right. So when we're presented with data like this, we know that we need to make some assumptions to translate between genome copies and infectious viruses. Next slide. At the most conservative end, we could assume that every genome copy corresponds to an infectious unit, in which case 10 million genome copies would correspond to 10 million infectious norovirus. Next slide. The DPR2 provides us new data on these ratios, and we see that it's not a static 1:1 ratio, but a wide range. So the TWG recommends that norovirus not be viewed as a simple linear distribution, but instead a band of potential values. In other words, 10 million genome copies could mean as high as 10 million infectious norovirus, but it might also be as low as 100. This example is meant to show some of the limitations of the molecular data and the difficulties in interpreting and using the data. Next slide. So we can wrap up DPR2 by looking at the main recommendations from the TWG. We recommend that the state board use the new high-quality pathogen distributions from DPR2. These data should serve as the basis for the raw wastewater inputs in the QMRA, which I'm going to talk about in the DPR1 section next. The TWG also recommends following rigorous QA/QC protocols that includes matrix spikes, and then using this information to correct the data for recovery. Given the challenges with interpreting molecular data, TWG recommends the use of culture-based data for developing the distributions. However, if the state board wants to use the molecular data, then we recommend following the framework laid out in the DPR1 final report. that accounts for important sources of variability, such as the ratio between genome copies and infectious viruses. Rather than use the discrete bounded data sets from DPR2, the TWG recommends that the distributions be fit to models so that they can be incorporated into probabilistic assessments of performance and risk. And finally, we recommend that the DPR2, QAPP, and SOP be used to set the bar appropriately high for any future pathogen monitoring studies. Okay, next slide. So we just looked at defining pathogen concentrations in raw wastewater. In DPR1, we put that information into a larger context. The goal of this project was to develop a tool to help regulators and others assess how much treatment is needed to meet our risk goals. Next slide. The main deliverables from this project were the development of a web-based tool called DPR Risk that walks users step by step through the processes of risk assessment in an accessible and transparent way. This is accompanied by a guidance document that trains users on how to use the tool and shows them all the flexibility that's built into the system. The guidance doc also contains 3 real-world case studies that walk users progressively through more complicated features of the tool. Next slide. So when we look at the inputs to the DPR risk tool, we see they're identical to the ones we've discussed previously. They take us from raw wastewater through treatment to calculate the amount of exposure that someone gets to these pathogens from drinking the water and the resultant risk. Next slide. The first input is the raw wastewater pathogen concentrations. And you see that users have access to a range of preloaded organisms in the tool, the same ones as we measured in DPR2. But there's also flexibility at the bottom here to choose another user-defined pathogen if something else, like SARS-CoV-2, for example, became another organism of interest. All these selections are made via drop-down menus in an easy and reproducible way. Next slide. Users also have flexibility to choose different levels of treatment. They can select either a single level of performance for the whole train, or they can enter in different trains process by process. We know that treatment for any unit process is going to vary over time, so the tool allows you to model performance data as either a point estimate or a distribution of performance. This is an important feature to allow for these probabilistic assessments that the previous DPR panel recommended. Next slide. We have 2 main outputs from DPR risk. The first is the probabilistic assessment of treatment train performance, or PADP, which allows users to evaluate the distribution of performance for any given train. So this is important when you want to assess the ability of different trains to comply with a given treatment target. The second major output is from the quantitative microbial risk assessment, QMRA, that shows the resulting risk profile from the treatment train. It incorporates all of the previous inputs to illustrate how well a treatment train can meet a given risk goal, such as the daily risk goal that's specified by the state board. So what I'm showing here are the risk profiles of a single train with different assumptions about failure. The longer or more frequent the failure, the more the risk profile will approach or cross this threshold. Next slide. One item that the TWG noted is that not all DPR projects are alike. At one end of the spectrum, we have TWA that could provide treatment exclusively at the AWPF before distributing the water. RWA, on the other hand, sends that purified water to a water treatment plant before distribution, providing another layer of protection. What's interesting is that there may be other non-treatment or management barriers that can also be present in these scenarios. For example, you may also provide blending or retention in a reservoir or a small groundwater basin before the water treatment plant. Both these management barriers can further improve the quality of the water by reducing the concentration of pathogens. And that happens either through commingling with another source water or buffering out any peaks of pathogens with a larger body of water. Next slide. The TWG and the State Board both noted that these projects can have different risk profiles. Next slide. Consequently, we built additional flexibility into DPR risk to quantify and account for these management barriers. And I'm showing here inputs for 2 of such barriers: blending, or the commingling with other waters, and dilution and mixing, such as occurs in a reservoir. There are other elements that can also be modeled here, such as the die-off of organisms in the environment. Next slide. So how do these elements impact risk? Imagine we start with the same AWPF treatment train for 3 scenarios. So the same treatment train for TWA, RWA with 10-to-1 blending, and RWA with a 1-month reservoir. I'm not including the benefits of the downstream surface water treatment plant in this example. And what we can see here is that in the absence of failures, these management barriers provide quantifiable benefits in terms of risk. Next slide. When we model in the impact of failure as well, we see that this benefit extends through multiple operational scenarios. The management barriers can help to complement treatment and control the risk. Next slide. What's useful about this aspect of the DPR risk tool is that we can understand and quantify these differences, which opens the door for allowing different DPR requirements for RWA and TWA. Next slide. So as we wrap up, we can look at the main recommendations from DPR 1. We recommend the use of the new high-quality data from DPR 2 as the basis for the raw wastewater inputs into the QMRA. Rather than use the discrete points, we recommend that the distributions be modeled so they can be used in probabilistic assessments like QMRA. The TWG recommends the use of DPR risk to perform probabilistic assessments of performance and risk. So at this point, we have sufficient high quality data that we don't have to rely on point estimates, but we can and should characterize these inputs with distributions. Finally, the TWG recommended that the state board develop frameworks that account for the benefits of non-treatment barriers in both RWA and TWA. Next slide. With that, I'd like to acknowledge 3 people who helped put together this presentation for you: Anya Kaufman, Dan Garrity, and Emily Darby. And I can open it up to questions.
Thank you, Brian. Co-chairs, what's your pleasure? Seems to me we have maybe as much as 15 minutes here for questions from the panel. Alternatively, we can move to the next presentation and save that time at the end. So Adam, Jim, I'll defer to you.
Yeah, I was just checking. Thanks for telling me how much time we had. I was just looking at the time in the agenda. I don't know if the panel has burning questions right now. Let's kind of deal with them, and then we can. That'll provide some additional time for questions on the DDW presentation.
Excellent. Well, I saw Amy up first. Dr. Pruden?
Yeah, thank you. I had a quick question. So I was curious if you got any insight into why the methods, the molecular methods didn't work so well for the viruses. Is it because they were inactivated by the treatment process? Is it because of recovery efficiency or inhibitors? I'm just curious because, you know, insight into why that is could help improve those methods, especially for ones where there aren't culture-based techniques.
Yeah, and that's a good question, Amy. I think the main factor was that we had lower concentration factors. We just weren't able to concentrate up the samples that went into the machine as well as we could for microscopy or culture. We ran, you know, these full suite of QA/QC controls. So we're sure that this is not an inhibition. This is not the impact of inhibition, since we ran inhibition controls on each one of them. Yeah, I think I could double check, but maybe it was about an order of magnitude lower sensitivity for the molecular methods. And so I guess they may have been kind of close to the cusp.
So are the concentration methods fundamentally different?
Yeah, let's see. We started with a single concentration method for all the pathogens. Prior to then, you know, we would concentrate a liter, say, of a virus with PEG until we got a pellet, and then from that point we would split and send part of that you know, reconstituted pellet towards culture and part towards molecular. But you know, we take whatever it was, hundreds of microliters of sample, and then extract that for the molecular assay, and then run one of the microliters of 50. So I guess there's just, you know, we couldn't, or whatever, 5 of the 50 or something, but just we couldn't run as much of that volume in the end.
Okay, understood. Thank you.
Yeah.
Jackie Taylor.
Yes. Hi, Brian. I enjoyed the presentation. I had a question regarding, I guess it's regarding concentrations of pathogens as well. And I was wondering if you were familiar with other projects throughout the nation or even internationally that also tried to characterize the pathogens in wastewater, and how, if so, how your results compared to their results.
Yeah, Jackie, we did do that. We did a lit review, and we set up a number of criteria. Mostly we were interested in looking at the US. So I think we started with 100 papers and boiled that down to sort of 12 to 15 that met our criteria. Into that collection, we also had a couple of studies that the state had used previously that were international. So I think Norway and Australia. And you can see, I just didn't have time today, but we have overlaid all of our results with those sort of best dozen studies that we identified in the lit review. I could tell you, I think generally, you know, we saw good consistency in this data set with those other ones. Sometimes we're kind of landing squarely in the middle. Sometimes we're above. For like enterovirus, I think in adenovirus culture, we were above, and sometimes we were lower. But all of that is available in the report.
Thank you.
Chuck Haas.
Yeah, hi, Brian. So this is one of the most extensive data sets of paired molecular and culturable virus I think I've seen. And I wonder if you have enough variability in the water quality to see if there was a water quality effect on that ratio. Did you look at that at all?
That is a good question, Chuck. And no, we haven't, although I think that is possible. If you remember, the idea with this sampling campaign was to try to explore the extremes low and high. And so we were pulling grab samples kind of at various times of day, days of the week, et cetera. So we could potentially go back and try to see, you know, if there was some seasonal, you know, or temperature-based correlation with these ratios, but we have not done that yet.
Okay. Great, Chuck Gerber.
Yeah, I was kind of curious why you didn't sample for reovirus. I mean, laboratory data sets are most susceptible to chlorine, but I know in our studies, in Nick Ashbolt's, it's in full-scale plants. It's often the only virus we're able to find that's infectious after oxidizing disinfectants. It must have some kind of unusual property, but even claims of CTs of 40 or more, we're still able to find reovirus. I know it's much more infectious to a virus, you know, the infectious ratio to viral particles is much lower, but I'm just curious because it keeps showing up in all our data after chlorine disinfection.
Yeah, Chuck, that's a really good question. I think we were originally hoping that we could do some studies that looked at removal of these viruses through the treatment plant. But since it ended up only being focused on the raw wastewater, that kind of helped us, you know, target which of the pathogens we're going to look at. I say that because I think if we were going to look at removal through a treatment plant, then that recommendation would be a good one. You know, look at some of these ones that are more resistant. I think our sort of some of our guiding principles in picking these pathogens to begin with was ones that had been previously, you know, used in previous regulations, et cetera. And we might have selected a different set of organisms had we been looking at removal.
Well, that may be okay too, because we almost find hardly any reovirus in raw wastewater, but we find it always in the treated wastewater. So there are other factors maybe going on. Also, when you look at the ratio of infectious to non-infectious virus, if you consider, I think it comes through, the sensitivity is different for a naturally occurring virus than a laboratory strain of virus. You know, I'll just give you the example. When I started my career, we used monkey kidneys and human kidneys, and relative cell lines, we would find 1,000 times more virus in raw sewage because they came from human beings and primates. But the other thing to realize is these viruses have not been adapted to these cell lines. So if you pass them, Dick Ward found the ratio in stools was 1 to 30,000, but if you pass it, it could get down to 1 in 100. So that's something to consider. It's the cell lines is varies, depends on the individual virus, whether the receptor is there, the strain, the type.
Okay, that's a good comment, and I think some of this came up when we were developing the QAPP, and I believe we did at least 2 passages for the viruses to try to capture some of this. So if we had negative responses in the first pass, we would do another passage, and sometimes up to 3 as well, I think. But it would be good to have you look at the QAPP. I'm not sure if that's part of this process or not, and give some comments on that.
Joan Rose, I think you're up next. Joan, I'm sorry, but we can't hear you, or at least I can't.
Yeah, I can't either. My lip reading's getting better since March 2020, but not
Okay,
that good.
how about now?
There you are. Yeah.
Yeah, my headphones, for some reason, my headphones went back to the other speaker. I was wondering about the colophage, whether, the colophage as a surrogate, an indicator, whether you might be looking at that in the future, or whether you had any data on that. Just because they're in higher concentrations, and we can start to look at mechanisms if we look at viable and culturable and then molecular with phage as well. So I'm wondering if there was any thoughts about looking at these other surrogates.
Yeah, Joan, and we did also sample for male-specific phage. For sure, male-specific phage, and we did some analysis to see how well that correlated with the concentrations of the other pathogens, and saw very little correlation, like those.
Yeah, I was thinking about in terms of removal and mechanisms.
Yeah, and that would be interesting to look at. Again, since we didn't get a chance to look at removal, yeah, we don't have much new data to share there. But yeah, it surely would. That sounds like a great idea. Something that you could measure with both of the assays, and it's a whole lot cheaper than these culture assays for the human viruses.
Exactly.
Yeah.
Well, it's curious, the wide range. I mean, especially in untreated sewage between, well, we know culture and cell culture is probably underestimating, but we're measuring apples and oranges when we're comparing in many cases in terms of the primer sets that we're using, and then which viruses are actually growing in the cell culture. So
yeah,
it's I think finding out more why to go to what Amy was talking about initially would give us more confidence in making this adjustment between the signal by PCR and then the culture. Is there any thought though about why not just get rid of all the virus signal by PCR via the methods?
Sorry, can you say more?
Why worry about whether they're culturable or not? Do we just get rid of the PCR signal altogether when we go through these treatment processes?
Yeah, by the end of the treatment train, you're saying, would we have any detectable viruses? I would guess no, just because we're providing so many levels of protection. So I feel like, yeah, in establishing the treatment requirements for viruses, this feels like still something that's, you know, worth doing to have these different data sets to try to, you know, figure out what to use to come up with virus removal requirements. But there are challenges with it. Yeah.
Thanks.
Okay, Mr. Co-Chair Adam, you see any other questions that you have? Want to kind of connect this, or shall we?
I think we're ready to move on.
Okay, well, Brian, thank you very much. I really appreciate your contributions today, and appreciate the help from Anya, Dan, and Emily. Thank you so much. I'm reminded, you know, as I reflect on this conversation we're having right now, if you haven't read the book, The Ghost Map, take the short time it takes to read the book, The Ghost Map. It's the story of London's cholera epidemic, and got a lot of really interesting pieces to it that are going to contribute to some of the way we think about things today. And one of the things that I'm reminded, it said something about that it's a great testimony to the connectedness of life on Earth, that the fates of the largest and tiniest life should be so closely dependent on each other. And I think it's interesting that we're having this conversation, and we are indeed dependent on each other. So with that admonishment to read The Ghost Map, which is a great book, I think we'll now turn to the next presentation, and I believe, Jing, you are going to serve this presentation as well. So we'll give Jing a second to transition presentations. Here we go. And Brian's. Adam, anything else while we're transitioning here? You're muted.
Yeah, I got it. I keep muting and unmuting. I guess we could just mention that we did archive a bunch of samples, not a lot, but we did archive some samples, and we're in the process of talking to CDPH right now on what's the best way to use those archive samples. And it may be, you know, it's a kind of a side question that we can bring up at one of the work group meetings to see if they have any particular input, if any of the panel members might have some input on that particular front, but not directly related to the DPR question per se.
Thank you. Good. Well, great context. Okay, now we're going to turn it back to the DDW staff to talk about pathogens on to go next level deeper. And remember that the idea here coming out of the 2016 feasibility study were that these DPR research projects would inform the regulations and ensure that they were protective of public health. We have now with us Bob Holtquist and Saeed Hafizanimi, who are going to tell us how we've done that. So Bob, I think you're going up first. Take it away.
I'll go first. Thank you very much. Okay, pathogenic microorganisms pose an acute threat unless continuously controlled by removal and inactivation. Thank you. First, an overview of the pathogen control requirements in the draft direct potable reuse criteria. We set pathogen reduction targets to achieve specific health risk goals. This involves selecting the reference pathogens, determining the tolerable risk, and calculating pathogen log reduction targets based on their potential occurrence in wastewater and the safe drinking water level. We promote treatment reliability by requiring multi-barrier treatment using diverse treatment mechanisms, and we require redundant, that is extra treatment above the minimum log reduction capacity necessary. We validate treatment trains to ensure effective pathogen reduction. We require online monitoring of treatment effectiveness for each treatment process. We set pathogen control point critical limits for each process, and we require a treatment control system that responds appropriately to pathogen log reduction deficiencies. You can turn it to the next slide for Saeed. Saeed will present the treatment objective material, and then I'll come back and talk about the the actual treatment. Saeed?
Thank you, Bob. Good afternoon. I'm Saeed Hafiz Nizami with the State Water Board Division of Drinking Water, Recycled Water Unit, and I will be talking about derivation of pathogen reduction requirements in our draft criteria. So first thing I need to talk about is that consistent with previous IPR regulations, we selected Giardia cyst, Cryptosporidium oocyst, and enteric virus as the reference pathogens for the DPR regulations. These are the pathogens regulated in the federal and California surface water treatment regulations, and therefore must be addressed in potable reuse regulations because municipal wastewater can also be considered a surface water. Next slide, please. So the objective of the criteria is to maintain a risk of infection equal to or less than a tolerable level of risk. The risk target of 1 in 10,000 infections per year, or 10 to the minus fourth per person per year, has been the long-standing public health risk goal in drinking water regulations by the US EPA. Now, because the cumulative annual risk estimates are driven by the highest daily risks, therefore a single day of peak pathogen inputs can cause the annual risk to exceed the target level. So the State Water Board wants to reduce the potential variability that could occur using an annual risk target by specifying a maximum daily risk objective. The acceptable daily risk is calculated as the annual risk target of 10 to the minus fourth divided by 365 days to yield a daily risk target of 2.7 times 10 to the minus seventh infections per person per day. So the reason for using the daily risk target is that, as I mentioned before, the highest daily risk estimates essentially drives the annual risk estimate. So meeting this daily risk target will ensure compliance with the annual risk target. So for example, if the highest daily risk was just above the 2.7 times 10 to the minus 7, the system would technically be in non-compliance with the daily benchmark, but that system would still be providing a safety factor of about 3 orders of magnitude when compared with the annual risk target of 10 to the minus fourth. Next, please. So here's an overview of our calculation of the LRVs in the draft DPR criteria. I'm going to go over the process that we use to determine the LRVs step by step. But first of all, I need to generally discuss the LRV determination approach, which has been a point estimate based quantitative microbial risk assessment, or QMRA. This approach that was used by the State Water Board relies on a single maximum concentration value for the reference pathogen, an assumed single volume rate of water consumption, and single values of parameters defining the dose response models. This approach is consistent with guidelines from the World Health Organization for regulating microbial risk from drinking water and recycled water, and is also the basis for the US EPA's safe drinking water LRVs for enteric virus and Giardia cyst. So in summary, the process is that the tolerable concentrations of reference pathogens in finished drinking water that correspond to 2.7 times 10 to the minus 7 daily risk of infection were determined using the selected dose response models for each pathogen. And then based on the maximum estimated concentration of pathogens in raw wastewater, the required LRVs for DPR treatment trains were calculated as the ratio between these two densities. Next slide, please. So as I mentioned, one of the steps is to adopt the maximum raw sewage pathogen densities. And to do that, we looked at the results of the DPR2 research project and also conducted a literature review for enteric viruses. We decided to use norovirus to avoid underestimating the virus risk. Norovirus is the most common cause of acute gastroenteritis in the United States. Is found in high concentrations in raw wastewater, is a highly infectious virus, and overall has the greatest potential to exceed our infection risk target. The maximum norovirus concentration in gene copies per liter based on a literature review and reviewing the meta-analysis of data available in the literature, was determined to be 10 to the 9th. The maximum number that we used was determined not to be an outlier. This number was similar to the range of other maximum concentrations that we saw in other references as well. And then the maximum concentrations for Giardia and cryptosporidium in raw sewage were consistent with the same values that we had used in the IPR regulations in the past. Next slide, please. So next task after selecting the estimated raw sewage density is calculating the tolerable densities for each pathogen of interest in the finished water, in determining what dose response model to use for this purpose, namely for norovirus and cryptosporidium, where there are multiple dose response models in the literature. We selected the dose response model that would result in a lower tolerable drinking water concentration, hence a more conservative LRV calculation. Other assumptions that were made in order to calculate the tolerable drinking water densities were the annual consumption of 2 liters of water per day for 365 days. And listed here are the final calculated pathogen densities in drinking water based on these assumptions that I just went over. Next slide, please. So after calculating the tolerable densities in finished water, the last step in the point estimate QMRA is to divide the raw sewage density by the finished water density and calculate the ratio, or in other terms, the required log reduction value necessary to achieve the risk target. So these numbers came out to be 16 logs for enteric virus, 10 logs for Giardia, and 11 logs for cryptosporidium. Next slide, please. So next, I want to talk about DPR1 project and the DP risk tool, as Brian Pexon already touched upon. So the DP risk is a web-based, user-friendly tool that, as part of DPR1 research project funded by the State Water Board, was developed by the Water Research Foundation. It is now hosted on the Water Board server. Specifically, the tool was developed to perform QMRA and PADI-P, as Brian mentioned earlier. So this tool provides several analysis capabilities, such as calculating distributions of daily and annual risk curves based on various input parameters, such as raw wastewater pathogen concentration, inputted into the tool either as a point estimate or as a distribution, treatment train components and their individual or overall reduction capacities for each pathogen of interest, and characteristics of exposure to the final product water, such as total ingestion rate and number of ingestion events per day, and finally, the appropriate dose response model for that pathogen. So we also use this tool to verify our calculated LRVs, which are listed here. So these are the output screenshots from the tool that we just used to verify our calculation of LRVs that I explained earlier. And furthermore, we utilize the tool in determining the extra LRVs needed for reliability of the DPR treatment trains, which is what I'm going to discuss next. Next slide, please. So next topic is on reliability of DPR systems. The 2016 DPR Expert Panel report emphasized on achieving reliability for DPR systems by using a treatment train that has redundancy and meets the performance criteria greater than the public health threshold LRV. So to achieve this goal, we decided to determine extra log reduction capacity by conducting a QMRA, incorporating a conservative critical treatment failure scenario for each reference pathogen. So we conducted the QMRA using the DP risk tool, which also allows for incorporating treatment train failure scenarios and evaluating the impact of that failure on treatment performance and the resulting daily and annual risk values. Next slide, please. So The conservative critical failure scenario that we applied in the QMRA included a set of health protective assumptions. First, the critical treatment process failing in our scenario is the advanced oxidation process using UV light or UV AOP, which is capable of providing maximum 6 log reduction for each reference pathogen. Second, the critical failure of the UV AOP is a power interruption that shuts down all UV lamps. And lastly, a reasonable UV AOP failure duration of 15 minutes is applied to this failure scenario. So the DP risk tool allows for the user to simulate the effects of a treatment failure on risks by specifying the magnitude, duration, and frequency of the failure occurrence. So all these parameters, as you see here, were inputted into the tool, and a QMRA was conducted to calculate the daily risk associated with this failure scenario. Next slide, please. So as I mentioned before, these extra log reductions were determined for each reference pathogen by conducting a QMRA of a treatment train and applying the critical treatment failure scenario that I just defined. So using the tool, we calculated the resulting daily risk of infection associated with the failure scenario. And then in an iterative process, we went back and adjusted the total log reduction value required to be added to the treatment train to ensure that the calculated risk of infection does not exceed the daily threshold of 2.7 times 10 to the minus 7. So the excess log capacity needed to achieve the target daily risk of infection with the failure scenario were determined to be an additional 4 logs for each pathogen, which are listed here. So with that, that concludes my presentation on how these pathogen log reduction values for DPR systems were determined. So I'm going to hand it over back to Mr. Bob Halkwitz.
Okay, thank you. Next slide, please. So I'm going to talk about the treatment requirements, and the relevant section numbers that I'm talking about are in the titles of the slides. So for each reference pathogen, the treatment must be designed to provide the log reduction required to meet the risk goal plus the assumed failure scenario. That is a 20, 14, and 15 log reduction for virus, Giardia, and Cryptosporidium, respectively. The treatment must provide at least 4 significant pathogen treatment processes. This ensures meaningful multi-barrier treatment. And they have to be from 1 to 6 logs, so we put a maximum credit on any given log so that to assure that you have to use a number of barriers to achieve the log reduction requirement. And the treatment must include at least 3 treatment mechanisms: physical separation, chemical disinfection, and UV disinfection. This provides the need for the diverse mechanisms called for by the previous DPR panel to provide robust treatment frame. Next, please. We require validation of each treatment process. This includes determination of the log reduction a treatment will achieve most of the time, and we've selected 95% of the time as our is the credit will log reduction credit will give for a process. 95th, so the 5th percentile log reduction is credited to the treatment. And the figure is a performance distribution for a process with the log reductions on the x-axis and the probability that the log reduction will be lower or the same on the y-axis. So the 5th percentile selected for the credit is down in the lower left hand where the probability reaches 0.05. So most of the time the process is performing better, certainly, than what we credit it for. And with multiple diverse processes in the treatment train, the train should be doing very much better than the sum of the individual validated processes. So even though a single treatment process has a small probability of underperforming, the treatment train is going to be reliable. The validation process must correlate performance of the treatment, the log reduction performance, with a measurable parameter and identify limits for that parameter, which would be the critical limit. Next slide, please. We've adapted the Australian water valve validation template for a potable reuse treatment validation. We've translated the Australian English into American English. Some of the steps that it required include identifying the mechanisms of pathogen reduction by the process. So we want to fully understand how it's achieving what it's supposed to be achieving to make sure the study is being done appropriately, no black box. We want to identify, the validation study has to identify the pathogens or appropriate surrogates for pathogens for use in the validation study. The study has to identify the influencing factors that affect the efficacy of the process, physical and chemical aspects of the raw water, for instance, and the operating conditions. It has to describe the method to collect and analyze the data. Again, the lower fifth percentile of the distribution demonstrated is the credited log reduction value. And it has to determine the critical limits to be used to determine when the process is working as designed and as demonstrated. The steps are actually identified in the criteria in more detail than I presented here. Next slide, please. This validation section also states that the treatment train log reduction is the sum of the individual validated process log reductions. It also states that the treatment train must include UV disinfection with a dose of at least 300 millijoules per centimeter squared. This last is an attempt to make certain we are addressing all the pathogens adequately, not just necessarily reference pathogens. And for any treatment train that may be proposed, that would otherwise be in conformance with the criteria. Next slide, please. There are opportunities to validate treatment for pathogen log reduction that may not be obvious or spelled out in the criteria. The treatment required for contaminants of emerging concern removal, that is the ozone BAC, the reverse osmosis, and the advanced oxidation. Those processes can be validated for pathogen reduction and in fact used to meet the bulk of the required log reduction. This is now being done for indirect potable reuse projects. As discussed by Jing and others, there are two types of direct potable reuse identified in California statute. Treated water augmentation, where the DPR project water can be put directly into the potable distribution system. And then raw water augmentation that has DPR project water going into pipelines or aqueducts that take raw water to a drinking water treatment plant. As been stated, the statute does not specify a type of drinking water treatment plant. It would not necessarily be a surface water treatment plant, excuse me. It indeed may not be a plant that reduces pathogens at all. So features of a raw water augmentation project that might provide pathogen reduction benefit treatment can be validated under these criteria. Such features as retention time, the drinking water treatment plant itself, regardless of what kind of plant it is, and perhaps even blending. I note that in the 2012 NRC exemplar, that blending was considered a barrier for pathogens, but we would need help, I think, figuring out how to calculate the benefit of that and how to validate that. Certainly assumptions have to be made about the densities of the two waters being blended. And the DPR risk tool, as was described by Brian, helps us evaluate these various barriers, these various features of raw water augmentation that might be of benefit. And some specifics are included in the criteria for evaluation of validation of surface water treatment plants. Next slide, please. The treatment train must be operated to achieve 20 log reduction of enteric virus, 14 log reduction of giardiasis, and 15 log reduction of cryptosporidium oocysts. And it must be done so continuously. The treatment train log reduction values must be tracked continually by the SCADA system using online monitoring to determine compliance with treatment process critical limits. And this is regardless of where that treatment is provided. The DPR project as a whole might have validated barriers in the conventional wastewater treatment, secondary treatment. It might have an advanced treatment facility where there'd be validated barriers. And then subsequently, there might be validated barriers in a surface water treatment plant or other water treatment plant. So the SCADA system has to keep track of what LRVs, what log reductions are being achieved by each process on a continuous basis so that it can make the determination whether or not certain criteria are being met. Next slide, please. The pathogen treatment must operate within limits. A DPR project must discontinue delivery of water to the distribution system if the treatment train is not achieving log reductions of 16, 10, and 11 for virus, giardia, and cryptosporidium, respectively. The treatment system must discontinue delivery, the project must discontinue delivery if the minimum number of treatment processes and the minimum number of mechanisms are not provided. And the system must discontinue delivery within 24 hours if the treatment train is not achieving the minimum design log reductions of 20, 14, and 15. So that means if the log reduction targets, including the redundant log reductions due to the failure scenario, are not being achieved, a DPR project has 24 hours to restore that treatment, or it must discontinue delivery of water. Next slide, please. Now, pathogen treatment monitoring and control. The treatment log reductions must be tracked continuously with a SCADA system using online monitoring for each process. It's actually, I think I previously stated. The control system must have associated alarms that indicate when the process is not operating as designed. The control system must be designed to identify a failure of a process to meet its critical limits. The control system must be designed to automatically stop the flow of inadequately treated water to the drinking water system before unsafe water reaches the system. This means the control system has authority to halt the flow, of course. This also means that there must be a flow path downstream from the treatment, from each treatment critical control point that allows time to fully implement the flow control before the distribution system is reached by the water. This section also states that the State Water Board must be notified if the project is required by the section to discontinue water production. Next slide, please. These last two slides deal with plans that must be prepared by the DPR project. They tell us how the project intends to comply with the various requirements. We can hold them to conformity with the plans by making them provisions of the permit. The first one is the operations plan. This plan must describe how the SCADA system identifies log reduction treatment performance and status for each process. The operations plan must describe how the SCADA system identifies a failure to meet the required log reduction and is able to automatically prevent water from reaching the distribution system, prevent inadequately treated water from reaching the distribution system. Next slide, please. The second plan is the pathogen and chemical control point monitoring and response plan. The plan must address the following points. For failure to provide 16, 10, and 11 log reduction of virus, Giardia, and cryptosporidium respectively, the SCADA system must identify the failure condition, alert the operator, halt the distribution of water, and generate a record of the incident. A pathogen control point parameter not meeting the critical limit means the process is not given its validated log removal credit. This may a critical control point response time is described in this section. The critical control point response time is the total time required for all steps involved from the time a critical limit failure occurs to the time flow to the distribution system can be completely terminated. These steps are identified in the criteria, and they include things like the period between sampling events, the time it takes the computer to determine compliance status with log reduction requirements, the time it takes a valve to close or a diversion valve to open, that sort of thing. The flow path from each critical control point must provide the response time. The plan must describe the time required and the flow path design. So these are the pathogen control requirements. Next slide, please. If we have time for questions. It's up to you, Kevin.
Bob, can I ask you a question?
Yes.
In listening to your requirements and in the diagrams, the direct pipe to pipe is shown without an engineered storage buffer. Realistically, wouldn't you need one, and wouldn't that affect a lot of the discussion?
An engineered storage buffer would certainly help comply with a lot of these requirements and some of the requirements you're going to hear about tomorrow. I think on my last bullet, I said you have to have a flow path that allows for the time to respond to a failure. So that can be a fairly significant time. So the engineered storage buffer could provide that time, but we're not requiring an engineered storage buffer specifically.
But on the other hand, you require treatment processes specifically.
Yes. Yeah. So what are the benefits of engineered storage? I mean, if it was the CSTR, you can get mixing to blend out peaks, and we have that requirement in the chemical control section. And you can have time to identify and respond to a treatment failure. And we require that in the criteria. So I think, certainly the use of an adequately sized engineered storage buffer could meet those requirements, but we've stated, I think, in the criteria, the reasons for doing that, rather than just specifying the need for some size storage buffer.
The only reason I raised the question is so many other things were specified, and yet some of these, for example, you would probably, for most applications, you would also probably need a cooling step, which is not, because it would change the chemistry of the distribution system to put in warm water.
No, that's true. And there again, we have other requirements. You know, it's the obligation of the project to make sure they're not creating any problems in the distribution system. If the cooling is needed to keep the water stable and avoid quality problems in the distribution system, but that obligation is already imposed on them without specifying the means of doing that.
But Bob, shouldn't that be part of the guidance? I mean, if you want it for, in other words, because you could conceptualize that someone might just slip through when you have a problem like Flint all over again or other situations. In other words, is that part of guidance or is that part of regulations as you see it?
Yeah, we've got a problem relying on guidance, as I'm sure has been alluded to by others. We can't enforce guidance, unlike the EPA, U.S. EPA.
But couldn't you include that in the engineering report that they must provide the results of an analysis of the distribution system?
Yes, we can, and we should require that. And if we haven't included that, and I don't specifically remember, I'm sure I know we intended.
I didn't see it in my reading of it, Bob, but it could well be there. I may have missed it.
No, I think we want to be very, and if you missed it, it's probably not clear enough. We want to be very clear in the criteria, what the project has to demonstrate in their engineering report, and then provide some narrative requirement that informs them or requires them to avoid any problems, any water quality problems. You don't want to jeopardize the operation of the distribution system. So if we're not clear enough in there, and this is an indication we're not, we'll go back and look at that.
On a similar note, shouldn't the engineering report detail that the operators of the wastewater treatment facility have done everything possible to produce the highest quality effluent for advanced treatment? In other words, the regs almost seem as though they pick up, I mean, that you pick up rather than you're reactive to what is left over rather than being proactive and saying, demonstrate to us that you've done everything possible to produce the highest quality effluent.
That's an optimization requirement, which we've used in a number of our regulations. And we usually, in order to write that kind of a requirement in a enforceable manner, we usually say optimize to minimize contaminants. Of course, as you're operating to minimize one contaminant, another one may be going up. So it's awkward. It's difficult to write that kind of a criteria. To write a criteria that makes sure the secondary effluent is as friendly as possible to the succeeding, the downstream advanced treatment. I'll have to think about how to write that.
Bob, the other question comes in other words, for example, in the two plants that are operating, there are no return flows to the headworks. I mean, And in Tillman, the same thing is planned, no return flows to the headworks, which affect the quality of the water with respect to some constituents.
That's true. I don't recall that we've addressed that at all in our criteria. I would expect George to bring that up too.
Yeah, can I just interrupt? I know Chuck has a question. I see he's there. I just want to interrupt for 1 second. I think there's a balance here, George, between, and we can deal with this in the various work groups, but between performance-based regulations that can be enforceable and adopted by the State Water Board. And I'm stepping out of bounds here, but pull me back, Bob, if you need to. And also, sort of in quotes, the guidance that the panel could provide for modifications and clarifications in the engineering report. And I think we can handle both of those within the work groups and partition out the panel's opinions and guidance back to the DDW staff in both those arenas. Is that a fair enough statement, Bob?
Yeah,
No,
well, you know, I mean, I think there are so many other things that could be done, for example, in source control that really haven't been discussed that impact the quality. And that's where my concern is, that we could certainly produce, for example, the two plants operate at constant flow. Orange County now is at constant flow, but San Diego will be operating at constant flow. And you get totally different performance from that kind of a plant as opposed to one with very high variable swings, and especially in response to climate change.
Yeah, George, I agree. And those things typically, this is a broad statement, typically can't be dealt with directly within a reg, but can be dealt with through and I'm using this term very loosely, guidance within what the engineers have to put together as part of their engineering report. So you can identify every step that they have to go through, every question to answer, independent of actually stating it directly within a reg. And that's as far as I want to go. I agree with you, George. Source control is one of the items that we're going to talk about directly as one of the work groups. So you'll have plenty of opportunity to raise all the questions there and how we can parse it out and send it as comments back to DDW staff. I'm totally with you.
Yeah,
I'd like to jump to Chuck at this point.
It seems to me there's a great concern about quality, but we say nothing about the operation of secondary treatment plants with return flows and grinding up of solids. I mean, there are so many things that you can do that will enhance the quality and protect public health.
I don't disagree, George. I agree.
Well, we'll revisit it, I'm sure.
No, absolutely, we will. Go ahead, Chuck.
Okay, Bob, I want to drill down to this intriguing issue of a process train with processes that act by 3 different mechanisms. So would an absorption system of some sort that removes pathogens be considered physical separation?
I don't think we'd envisioned that, actually. We were talking about, some sort of a membrane.
Okay, so in effect, there's an absolute membrane requirement in that case.
I believe that's certainly what I had in mind when we wrote that.
Okay. Because I know there's a big developing literature on systems without membranes to achieve similar objectives. And actually, Jorg may know more about this than I.
Yeah, anyway.
It's a really interesting question.
Yeah, I had a similar question in that I've often heard the California framework is boiled down to direct potable reuse equals having reverse osmosis, having a membrane. And so I think that's important to clarify, in terms of now we're talking multiple barriers. Does one of those have to be a membrane?
Yeah, it's my, when we wrote the criteria, and somebody else from our group can chime in if I'm wrong. I think we were definitely we didn't necessarily for this pathogen section, not requiring reverse osmosis necessarily. That's a chemical treatment requirement for which there, alternatives may be possible. But I believe by saying physical separation, we definitely intended a membrane of some sort. Now, if adsorption arguably meets that definition, we have to think about whether or not we've been specific enough in the criteria.
Randy, did you want to add something?
I was just here to support Bob if I could jump in, but he's been answering it perfectly as it goes. So, no, I'm just here in case I can add anything.
Appreciate it.
Excellent. Well, 1:52. We've still got 7 or 8 minutes for additional questions and answers from the panel and from the DDW staff. Other questions out there from the panelists? Maybe anybody we haven't heard from who's sitting on a question? This is a good time to take advantage of this kind of focus time we have with the DDW staff.
Kevin, we just got all this material. As panel members, what are we supposed to do now?
George, this is Adam. One of the things we're going to talk about tomorrow in closed session is more details on how the panel is going to operate. Jim provided just an overview slide and said, 4 to 5 meetings, kind of a general time frame, no specifics, and then 5 different work groups. In the closed session tomorrow, we're going to sit down and take a look at where people want to be in those different work groups. He mentioned 5 different categories. What we're going to look at in terms of the details that was handed to you and what you should look at versus what you can, look at your leisure versus what you need to read to be prepared for the work group discussions. So we're going to go through that tomorrow. And the quick note we sent you was don't stress over reading all the stuff that we just sent until we actually kick off the work groups, define them and kick them off. That gets you close enough to an answer?
Yes, that clarifies it.
Okay, thanks. Hey, Bob and Randy, I think one of the responses to the question about is DPR equal to a RO membrane or some kind of membrane is that the alternative clause that you guys mentioned early on. The real question that I think one of the work groups should sort of noodle on is the question of how flexible are the regs to deal with improvements in technology over time, or would that improvement would the regulations, if adopted, be a barrier to new technologies coming in without significant modifications of the regs? So that would be one of the questions that we would pose to that work group. How do they view it? How do they see it? What do they see on the horizon in terms of technologies, et cetera, et cetera? And to provide you guys some opinion and guidance on that particular clause and that particular subject.
Right, we appreciate that because that was one of the things that we were focusing on as we developed the regulations was we didn't want it to be locked in and stagnant with current technology. We wanted it to be able to be something that could be incorporate future technologies that come out. And that's what the whole alternative clause is for. So we appreciate it.
Yeah, so we'll get, there'll be some self-selection going on in these work groups, but at the same time, all panel members are invited to any one or more of the work groups. It's not, closed. It will initially, and I'll mention it here so the public hears it, is these will be closed meetings. We will invite DDW in on certain discussions, obviously. We will make sure that whatever recommendations come out of those work groups are discussed with the panel, the full panel, and that we will be reporting out on those discussions to the public at the subsequent panel meeting. So that's the general framework of how we see this going. So there is transparency in terms of what we discussed, not necessarily when it's happening, but what we discussed, what the panel or work group decided on, and then discussions with DDW, et cetera. Okay.
I just had a little quick nonsensical comment to make. I was struck, a little thrown off a little bit by the fact you went to talking about the 16, 10, 11 log reduction rules just after somebody talked about the fourfold addition to those log reductions in practice. So somewhere in that transition, say, since we're in failure, we drop the upper four or what? I mean, just it seems to me there was a transition there that needed to be made to make sure people understood why you were jumping down to the lower numbers. You look puzzled, Bob. I must have got you.
So maybe Bob or Randy can answer it. I don't want to answer that one.
Yeah,
well, I don't need an answer. It's just that I'm just saying that there ought to be a transition there that says you're forgetting about the additional 4 logs that apply to a failure to protect against failure.
Yeah, one way of looking at it is given the numbers we use for occurrence in the raw wastewater to get down to safe levels, you need 16, 10, 11. And then, so that's the bottom line. You need to achieve that all the time or the water's unsafe.
That's what my family realized, but I'm just saying, I think you put down numbers 2014 and 15 in the previous, and I just think people are confused enough by numbers anyway. And it would make it, you're already in that's not operable. You just need to state it. That's not operable when you're actually dealing with a failure. All you need is a 16, 10, 11.
That's, in the ideal world, well, we're in our conservative view of the ideal world, that's what you would need to get down to safe water. But we recognize that there's failures that could occur that the SCADA system might not adequately respond to and halt the flow. So we've got a design requirement, is another way of looking at it, a design requirement for building in some redundancy to address that possible failure scenario. You don't have to operate that way all the time. You've got to try to, but should you lose some of that redundant treatment, you've got 24 hours to correct the problem. So yeah, no, I can see we haven't been sufficiently clear on that.
Mr. Chair, it's 2 o'clock exactly. I think Dick just asked a question. I think this, comes. I think we have an opportunity with some of these terms to get, a little bit more comfortable with them and, be more disciplined in our use. But I think it's a good concept that, maybe failing doesn't meet the standard of allowed to be operational still. But we'll have a number of opportunities like that, as Adam and Jim have mentioned. It's 2:00. I see, Joan, you've jumped on. Did you have a question or a comment that you wanted to make this morning? Okay, or this afternoon? Thank you.
No, just,
Okay.
thanks to Bob and Jen.
Yeah, Adam, anything else before we wrap up today and then look forward to getting together tomorrow at 10 a.m.?
No, I think we're there. I think people are probably tired of sitting and listening, and I think we're ready to move on to something else, and then tomorrow we'll pick up on the chemical side. And again, I mean, we could go back, but more, as you noodle on some of this stuff tonight when you're sleeping, either a nightmare or a dream, a good dream. You can ask questions tomorrow on the pathogen subject.
Hey, there's some comments in the chat as well. So I guess you guys will be saving that chat, right?
I hope so.
Yes, we will save that chat. We won't lose that. And
Okay.
I hadn't looked at that in a while. It's funny. Yeah, Adam, anything else? I feel like we've accomplished our objectives for today. I really want to thank Brian for his contributions. The DDW staff, great job pulling your presentations together and dialing them in for this group. I think we've done an excellent job of setting that baseline and giving the panelists some opportunity to kind of identify issues that are important to them. We've got a full agenda tomorrow. I look forward to seeing you all back here on this call at 10 a.m. and to facilitating some public comment before we move into our first closed working session of the panel. So with that, we'll sign off. Wish everybody a good day and wish everybody to be safe and well. Take care.
Thank you.
Thanks.